Acting like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Whoa, mama, the queen of love promised me that I'd be fine by tomorrow. Whoa, mama,
पर प्रैक्टिस में तो माइक अभी अवेलेबल था नहीं। यस स्पीकर एंड माइक, हाँ इसी के माइक से। यस यस। तो अब मेरे ख्याल से आवाज जा रहा है। हाँ। 1 मिनट के लिए सब लोग शांत रहिए। 1 2 3 माइक 1 2 3 चेक। इस स्पीकर में आवाज नहीं है। इससे ही आ रहा है स्पीकर ही। अच्छा तो वो मतलब चालू है।
क्यों माइक ये वाला यूज करो।
हाँ
इसी के लिए
इससे है सफिशिएंट आवाज चल रहा है। हाँ ठीक है काफी मतलब 1 2 3 4 चेक। यस ठीक है ओके फाइन सब चल रहा है। इसमें कोई नहीं है और हमने यहाँ पर डाला नहीं वो सब प्रैक्टिस सेशन यूट्यूब में लाइव जा रहा है।
हाँ अब वीडियो प्ले करते हैं।
हम वीडियो प्ले करते हैं। तो मेरे ऐसा लाइव ऑन यूट्यूब पे कोई नहीं है तो इसमें अंदर ही I don't know what's going on. Now all the love that's in my heart is flowing like the Amazon. 'Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Oh mama, oh yeah. All the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Oh mama, oh yeah.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning to everybody.
Good morning, sir.
Good morning, Prasad.
Good morning.
Good morning.
I think for 2 minutes you can play that video what you were playing earlier. हेलो आ गए हाँ मैं क्या बोल रहा था वो जो वीडियो चल रहा था ना उसको तो चालू रखो हाँ कर ओके आ गए हाँ, मैं क्या बोल रहा था वो जो वीडियो चल रहा था ना उसको चालू रखो हाँ कर ओके
सर्वेषां शान्तिर्भवतु सर्वेषां स्वास्थ्यर्भवतु सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामया Om Shanti Shanti Shanti. May the world be blessed with peace. May everyone be healthy. Let there be no illness. Let there be no pain. Let there only be happiness and peace everywhere. A very good morning to our guest speakers, faculty members, and participants. And those joining us from Japan, we wish you a very good afternoon. I am Sanandan.
And I'm Siddharth, and we will be your hosts for the day. We are joined by our co-hosts, Rubini and Brunda. Of Foreign Affairs, Japan.
This year, 2022, marks the 70th anniversary of the establishment of the diplomatic relations between Japan and India. The two countries have a long history of shared economic, scientific, and cultural cooperation. DeW 8.0 celebrates this very spirit of collaboration and innovation. This year, our theme is Future of Design Thinking and 3D Printing in Healthcare.
Before we proceed, we request all participants to please keep the microphones on mute and maintain the decorum of the event. All sessions will be streamed live on YouTube. The link can be found in the chat box.
Now, I would like to invite the DeW 8.0 coordinator and head of design discipline, Dr. Prabir Mukhopadhyay, to give the inaugural address.
Thank you.
Very good morning, all of you. Esteemed guest of honor, Ms. Sato Hitomi, all dignitaries from Japan and India, esteemed speakers from Japan and India, respected Chairman Sir, DOG, IIIT-DM Jabalpur, respected Director Sir, IIIT-DM Jabalpur, my faculty colleagues, all staffs, officers, friends from the media, entire coordinating team of Design Workshop 8.0, ladies and gentlemen. I welcome you all to this Design Workshop DeW 8.0. The theme of this Design Workshop is Future of Design Thinking and 3D Printing in Healthcare. This Design Workshop comes at a time when the world is reeling in a pandemic, and we are all facing this pandemic situation. So if you look at the title of the workshop, it is Design Thinking and 3D Printing. So what is design thinking? So we use some of the principles in design in different facets of science, technology, and healthcare also. So if you say what is design, design is problem solving, design is opportunity mapping, and design is value creation, the list goes on. So what is design thinking? what is that specificity about design thinking, which makes it applicable in all the different domains that people are talking about today, especially in the domain of healthcare. In a nutshell, if you have to talk about design thinking, it's a set of philosophy and a set of rules. In design thinking, we follow certain steps, right? We ideate, we prototype, we test, and so on and so forth. And these steps are not in a sequence, 1, 2, 3, 4. Okay, we can go back and forth. But the main purpose of design thinking or application of design thinking is to see product, to see space, to see communication from the lens or through the lens of humans or through the lens of the users to make it much more user-centric. And that's what this workshop aims at. Now we have design on one hand, design thinking on one hand, and we have technology on one hand, which is 3D printing, which we are going to discuss in this entire workshop. So it is essentially a technology-empowered design that this workshop is going to touch upon. I'm happy to say that as I speak to you, we have more than 520 participants all over the world today. We have 10 speakers for this design workshop, 6 speakers from Japan, and 6 speakers from India, and we have 4 speakers from Japan, and each of the speakers are going to cover different facets of design. Some of them are going to talk on autonomous healthcare system. Some of them are going to talk about medical equipment design. Some are going to talk about the application of 3D printing in different facets of design. So I hope these 15 sessions that we have arranged for you in different facets of healthcare, and it's a unique example of the fusion of design and technology, which we will be able to showcase to you through our esteemed speakers. Our speakers are all stalwarts in their own domain, and I hope you will enjoy their sessions. So with this, I would like to welcome you once again on board. I hope you will have a wonderful time these 3 days of the workshop. Please feel free to ask questions because we have question and answer sessions. This entire program is also being live streamed on YouTube. So thank you, all of you, and welcome on board once again to this Design Workshop 8.0. Thank you very much.
Thank you, sir, for your opening remarks. Now I request Professor Prashant K. Jain, DeW 8.0 co-coordinator and head of Mechanical Engineering Department, to please introduce the director.
Very warm good morning to all of you. I am glad to introduce our director, Professor Praveen Neminath Kondekar. He holds an MTech from ISC Bangalore and PhD from IIT Bombay. His research area is in electronic circuit design and nanoelectronics devices and circuits. He is the most popular teacher among students due to his interactive way of teaching. He has a wide range of experience of teaching and research in private public sectors and international educational institutions. He worked as faculty in world ranking 42 Korea Advanced Institute of Science and Technology, South Korea, for 6 years. He also served as founder director of Symbiosis Institute of Technology at Pune. He joined this institute as professor since 2010 and immensely contributing on all aspects of institution development, including teaching and research. I would welcome Professor Praveen Kondekar to please enlighten us on this occasion of inaugural of the design workshop. Thank you.
Director, sir, we request you to please unmute.
Okay. Okay. Thanks a lot, Prashant. I'm very happy to address this gathering. Today's guest of honor, Ms. Sato Hitomi, Senior Regional Coordinator, Southwest Asia Division, Ministry of Foreign Affairs, Japan. Our Honorable Chairman, Sri Deepak Gaisaji, esteemed speakers and participants across the India and also Japan. It gives me immense pleasure to welcome you all on this 8th design workshop, which is a flagship event of our institute in collaboration with consortium formed by Japanese universities and industries. We are really grateful for Ministry of Foreign Affairs Japan for supporting us in hosting this event. This year, the workshop is focusing on future of thinking, design thinking, and 3D printing in healthcare. As we are aware that 3D printing is creating an enormous opportunity for medical industry. According to a report by market research firm, the market for medical 3D printing is currently estimated at around 1 billion, and it will be by 2027 will be around 7-fold of this. And that clearly indicates that the potential for 3D printing within the healthcare is huge and is set to hold the fundamental position in the future of healthcare. Today, the technology is facilitating surgical team both inside and outside the operating room. Inside is for most efficient surgical tools, and outside in medical education by state-of-the-art anatomical models for learning. Furthermore, the 3D printing enabled dental products, especially the very cheaper and faster, and enables the personalized care through custom produced instruments and implants. So more and more leading hospitals and labs are now adopting 3D printing as part of their medical practices and research effort. All in all, the future of healthcare looks very different from the healthcare of today. And 3D printing will be one of the key technologies to drive forward this exciting, meaningful transformation. I sincerely hope that this workshop would benefit the participants from the expertise of our esteemed speakers from Japan and from India. I'm grateful to Professor Ito for helping us in coordinating with all esteemed speakers from Japan. And I'm extremely glad to mention here that this year the workshop is endorsed by the steering committee of the 17th anniversary of establishment of Japan-India diplomatic relations, and the logo of 70th anniversary of Japan-India friendly relations has been showcased on all promotional materials of this design workshop. And this is a testimony of the stronger relationship between our country and Japan. I would like to thank the organizer and all the volunteers for their hard work and all the efforts they have put in for over past several months to make this event successful. I wish workshop and all the participants to gain from this 3 days meaningful workshop for all of us. Thank you.
Thank you, sir, for your valuable words. Now I request the director to introduce the chairman of the Board of Governors.
Oh, thanks for giving me this opportunity to introduce our Honorable Board of Governing Chairman, Sri Deepak Gaisaji, a most inspiring personality and the guiding force for our institute. He is a qualified chartered accountant, cost accountant, and company secretary. He is an alumni of prestigious London Business School. At initial stages, he began his career with Radhakrishna Group and Tata Unisys. He is the founder, chairman, and chief mentor of a healthcare and biotech company, Gencowell Strategic Services Private Limited. Strategy development for global healthcare is what is the vision of this company. He is the first Indian to win the most prestigious Chief Financial Officer of Asia Award. He was the director and vice chairman of iFlex Solutions Limited, CEO Indian operation, and CFO of iFlex Solution Limited India. Sri Deepak Gaisas is also a member of Executive Council, the NASSCOM, that is National Association of Software and Services Companies, and Western India CII, that is Confederation of Indian Industries. He's also guiding us as a board of member. He's also guiding us on various boards of members for several companies, especially pharma and retail, such as US Vitamin, Shopper Stop, City Crop, Stemed Biotech, and so many others. Innovation to activation is the main theme, tagline of his company, Gencowell. Dear participants, please welcome Sri Deepak Gaisas ji to share with us his expertise and guide us. Thank you.
Morning, Professor Kondekar, thank you very much for your introduction. And I welcome guest of honor, Ms. Sato Hitomi, the regional coordinator for Ministry of Foreign Affairs, Japan. And I thank all the sponsors and people who endorsed it. I also welcome the speakers from Japan and from India. And I'm very glad this 8th conference, design workshop, has titled Future Design Thinking and 3D Printing in Healthcare, especially healthcare. Whenever I look at 3D printing in the first place, my perception more of a common man is that currently the way in which 3D printing is used is more to create some objects which nobody wants or nobody needs. So I think one of the major things that entire designing in 3D printing is required to be guided to create something which society wants, which people want, which industry wants. And we need to move towards that because the teething problems of 3D printing are getting over. And therefore something useful coming out of 3D printing is what industry is looking for. When I look at the designs that can come in future, maybe in furniture or maybe in castings and dyes and so on. But what I mainly feel that the 3D printing is going to be used more, what we term as mass personalization. For example, if I want to buy a shirt, why should I buy a shirt which is made by somebody else? But I can buy the shirt that I want to design myself and get it printed on 3D printer. That is something that what we are looking for, and maybe the mass production will be converted into mass personalized production. And that's what probably 3D printing is made for. I would also urge people to, and especially the experts like you, to look at both nature and India. Nature in the sense that nature has such a beautiful designs for various things created by nobody or by somebody we don't know. But we can learn a lot of designs from the nature by itself. And I think when we keep our eyes open, and I especially envy people, students and professors in IIIT Jabalpur, the kind of nature that you see, the kind of nature that you come close to. I think there are a lot of things that you can design, you can learn, you can observe, and try to take from that what new designs can be created based on 3D printing. Another thing I always look at when I say India, I think there is a lot of rural India that remains, and what we call sometimes little funnily, that it is a jugaad. And jugaad is something what is rural Indian people for ancient Indian times, that they have been using the things in a particular design way that we are not even aware of, but that's made their life very easy. And when we look at these things, I think there are a lot of designs that can be learned from, and we can use them in industrial purposes or even for the healthcare. And that's what I say that one should look at when we talk about designing. We should look at nature and the rural India jugaad, as we call it, and see what we can take from them. And rather than reinventing the wheel, use their experience and wisdom of both nature and people to see what we can convert that into a value creating proposal. It is not just a question of creating prototypes, because that is what currently things are used for. But I think from prototype, we need to get to the actual manufacturing production. And I'm sure next 2 days, probably you guys will discuss those kind of things. Now, coming to healthcare, I think what Professor Kondekar said, that healthcare designs and equipment are going to be the topmost market, probably $1 trillion market, I would say. And when I say healthcare, I don't mean disease management, but healthcare is taking care of the health. And that is where I think a lot of designing is required, right from hospitals to our homes, and the way in which our lifestyle is. I think, can we make it more convenient, so to say, by creating these new designs in healthcare, which will take care of our health. And that can be all kind of well-being equipment, the procedures that are carried out in the hospitals, and so on and so forth. And my suspicion is that the way in which currently the engineering is moving ahead in healthcare area, my suspicion is that one day in operation theater, there will not be any medical professionals, but there will be a lot of robots being operated by engineers sitting outside the operation room. And that kind of scenario is likely to come in near future. But more than that, since I work in also the biotechnology, my dream, or sort of, I would say, blue sky thinking, is that when I use my stem cells or mesenchymal stem cells derived from the dental pulp, can I use these stem cells or the secretion coming out of stem cells and use 3D printing to create organs of body? And so if I take my dental pulp stem cells and I use these mesenchymal stem cells to create my kidney or create my liver by way of 3D printing, I think that may sound like mad idea at this point of time, but every innovation, I can promise you, sounded like mad idea in the beginning, but turned out to be the great idea and great value creator. So my blue ocean thinking is really that creating an organ factory one day with the help of 3D printing, use your stem cell secretions and create organs for the people, whereby their life after 70 especially, and I'm sure the life expectancy in Japan is over 100. So a person, I was told by somebody that expectation is that 80-year-old person will be going with his father to meet his grandfather on a golf course. I mean, if that is going to be the life expectancy, then the dignity with which we need to live between 70 and above is something which biotechnology or healthcare will solve. And that is my firm belief. And I'm sure the 3D printing will help in creating this organ factory. Again, as I said, may sound today as a mad idea, but probably by 100 years down the line, it will be a reality, and I'm sure it will be a reality. Unfortunately, we won't be there to enjoy that reality. But this is my sort of thinking. So medical engineering is great, and I think the subject that you've taken is wonderful. The speakers are very eminent. They are their own wisdom in their own fields. And I'm sure all you participants are going to get benefited immensely in next 2 days. I'm very glad to see the great participation as well from all over the world. And I wish all the best for this 8th seminar on design thinking and 3D printing in healthcare. I thank again the Institute. You guys are doing a great job. Continue to do the great job. Unfortunately, we can't meet in person today, but I'm sure by next year, the 9th conference will be in the premises of the Institute, and all of us can meet again and discuss further, because I think whatever you say, the e-meetings have their own drawbacks, and personal meetings are more networking and bonding, and you can read the body language of people. I think that's going to be more important to us, and I'm sure next conference will be of that kind. So I wish again best luck, and thank you to all the teams who made this conference possible. Enjoy the conference and learn a lot of things. My suggestion is, Professor Kondekar, if we can come out with the paper ultimately at the end of 2 days and tell the world that what we discussed and what things can come out of this, that will be a great document to follow subsequently and look for. Okay, thank you very much again, and all the best. Bye-bye.
Thank you so much, sir, for your valuable words. Now, I would like to invite the DeW 810 coordinator and the head of design discipline, Dr. Prabir Mukhopadhyay, to introduce the guest of honor.
Ladies and gentlemen, it gives me immense pleasure to introduce you to our guest of honor today, Ms. Sato Hitomi. Ms. Hitomi is the Senior Regional Coordinator, Southwest Asia Division, Southeast Asia and Southwest Asian Affairs Department, Asian and Oceanian Affairs Bureau, Ministry of Foreign Affairs, Japan. Ladies and gentlemen, please join me in welcoming Ms. Sato Hitomi for her address to the gathering today. Ms. Hitomi, please.
Thank you for the introduction, Professor Mukhopadhyay. Professor P.N. Kondekar, Director of the Indian Institute of Information Technology, Design and Manufacturing, Jabalpur, Shri Deepak Gasas, Chairman, Board of Governors, distinguished participants and students, ladies and gentlemen, Namaskar. It is my honor to join the Design Workshop 8.0 today. First of all, I would like to express my gratitude of the faculty members and students concerned of the Institute, especially Dr. Prabir Mukhopadhyay as coordinator for organizing this year's Design Workshop. The cooperation between Japan and the Institute started when the Ministry of Foreign Affairs of Japan and the Ministry of Human Resources Development in India signed the memorandum in December 2006. This memorandum was made in accordance with the joint statement of the Prime Ministers of Japan and India in April 2005, in which the two sides agreed to make every effort to collaborate towards the development of the Institute. The main objective of this cooperation has been to raise young IT engineers who have learned the Japanese style design and manufacturing technology through merging the advantages of both countries, namely India's IT and Japan's design and manufacturing technology. When we have noted with pleasure that till now there are already many brilliant graduates of the Institute who are actively involved as bridge of Japan and India. Since the signing of the memorandum, many Japanese experts have visited the Institute to cooperate in supporting the formulation of the curriculum, giving lectures, and interacting with the faculty members and students. Although in fiscal year 2020, we could not make much activities due to the COVID-19 pandemic, this period gave an opportunity for Foreign Ministry of Japan and the Japanese Task Force for the cooperation with Institute to look back and review our cooperation for the last 15 years. We have evaluated our past cooperation and concluded that the first objective of supporting the formation of the curriculum in the Institute has been achieved. This evaluation has been shared with senior members of the Institute. Based on this evaluation, the Japanese side considers it appropriate that in coming years, exchanges and collaboration in academic research activities should be further promoted. Since March last year, both sides have discussed how to promote collaboration in academic research and started our efforts to make forward towards the promotion of joint research activities. The Japanese side received proposals from joint research from the Institute and have tried to find their counterparts in Japan. I'm pleased to state that till now, several proposals are advancing for joint activities between the faculty members of the Institute and the Japanese professors of various universities and institutions. We hope that through these joint research projects, the both sides will deepen mutual understanding and advance cooperation of research work, which would lead further people-to-people exchange between Japan and India in the academic field. For the last 2 years, unfortunately, we could not have actual exchange of people due to the pandemic. However, this year we have started new program. Since January, Japanese experts have started giving online lectures on cutting-edge themes. And Professor Ito, our eminent member of the Japanese task force, has cooperated Dr. Mukhopadhyay for organizing this design workshop 8.0. And 4 experts from Japan are participating. These experts are Professor Dr. Tsutsumi Etsuko, Hokkaido School of Commerce, Professor Yoda Nobuhiro, Tohoku University, Chief Researcher Dr. Ilona Hoffman, R&D Center for Teijin Nakashima Medical Corporation, and Mr. Yamamoto Masahiro, Nakamura Tome Precision Industry Corporation. I am confident that these 4 experts will contribute to the design workshop with their respective expertise. You may know, as Professor Kondekar explained, this year commemorates the 70th anniversary of the establishment of the diplomatic relations between Japan and India. We sincerely hope this year opened a new chapter of our cooperative relations between Japan and the Institute for further enhancement of the collaborative relations and academic research in the area of IT and design and manufacturing. Before concluding my remarks, I would like to take this opportunity to express my heartfelt gratitude to the members of the Japanese task force for their dedicated work, as well as the Japanese consortium members for their contribution and their continuous support. I also express my sincere appreciation for the faculty members of the Institute for their kind cooperation. Lastly, I wish all the best for successful and fruitful design workshop. Thank you very much. Dhanyawad.
Thank you, Ms. Hitomi, for your enlightening message. Now, I would like to invite the DeW 8.0 co-coordinator, Professor Prashant K. Jain, to deliver the vote of thanks.
Thank you, Siddharth and Chet. I extend my heartiest welcome to our guest of honor, Ms. Sato, Senior Regional Coordinator, Ministry of Foreign Affairs, Japan. Respected Chairman, Sir, Board of Governors, Sri Deepak Ghaisesji. Respected Director, Sir, Professor P.N. Kondekar. All dignitaries from MOFA, esteemed speakers, participants, all my faculty colleagues, officers and staff. Thank you all for so much for making it to this inaugural session. We are very thankful to Professor Ito, who has been instrumental in coordinating with all speakers from Japan. Your benign presence, in spite of your busy schedule, has certainly encouraged us to take this workshop to its fruitful conclusion. At the outset, I would like to express my deepest gratitude to you all for helping us make this design workshop happen. Without the active cooperation of yours, this would not have been possible. We are also thankful to the technological development by which we are able to conduct the event in virtual mode. I would like to take this opportunity to thank all the different committee members, student volunteers who have been working for months to make this event successful. My sincere thanks to Dr. Tripti Singh and her team of student volunteers from design discipline who have worked very hard in designing all the promotional materials, including the website. I would also like to thank the entire IT team led by Mr. Aditya Sharma for providing all infrastructural and manpower support in streaming this event online. I thank each one of you from the core of my heart and trust that we will receive your wholehearted cooperation throughout the workshop in these 3 days. A special thanks to our friends from the media for giving wide publicity to the event. At the end, I would again thank all of you for your wholehearted participation and cooperation in the event. And I hope and trust that we will be able to meet physically for the next design workshop in a pandemic-free world. Till then, stay safe, take care, Jai Hind.
Thank you so much, Prashant sir, for those kind words.
We have lined up a series of talks by esteemed designers and scholars from India and Japan. This event would not have been possible without the dedication of members of the faculty and my fellow volunteers. We would like to thank them all. A special thanks to the audience for their enthusiastic participation. Hope you all have an enriching experience at DeW 8.0. We have now reached the end of the inaugural session. We shall part for a 30-minute tea break. The first session shall begin at 12 noon. We look forward to your presence on the same link. Now, I request all participants to please rise for the national anthem. Thank you.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
थोड़ा सा रात भर बैठ के थोड़ा उसको मॉडिफाई किया। हाँ हाँ, नहीं बहुत बढ़िया, बहुत बढ़िया। नहीं वो तो डिजर्विंग है, नहीं 100%। वो मैं पहले मुझे लग रहा था कि बट नाउ आई गॉट वेरी गुड।
I'm dancing like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine, but Dancing like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. 'Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'll be fine by tomorrow. Oh mama, oh yeah. within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'll be fine by tomorrow. Oh mama, dancing like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. 'Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'll be fine by tomorrow. Oh mama, oh yeah.
Okay, hello. Am I audible? I'm Professor Kuse from. Oh, nice. Fine.
afternoon to one and all. I'm Rubini and I'm joined by my co-host Brinda. Welcome to the session 1 of DeW 8.0. We will begin with the session on applications of 3D printing. This session is also being live streamed on the official IIIT-DM YouTube channel. The link can be found in the chat box. Participants can send their questions to the Q&A profile in the chat box. I'd like to invite Professor Dinesh Kumar V from the Electronics and Communication Engineering Department to please take over.
Thank you. So, dear colleagues, students and participants, welcome to the first session of the design workshop DeW 8.0. We have Professor Abhay Kumar Madhusudan Uthe, who is going to speak on the 3D printing and design of innovative class C&D medical devices from Atmanirbhar Bharat perspective. The topic is very much aligned with the theme of the workshop, which is the future of design thinking and 3D printing in healthcare. It is my privilege and honor to introduce the speaker, Professor Abhay Kumar Madhusudan. Professor Madhusudan is presently a professor in higher administrative grade in Mechanical Engineering Department at Visvesvaraya National Institute of Technology, VNIT, Nagpur. His areas of research mainly pertain to the rapid prototyping and layered manufacturing. He began his career in 1986 after Bachelor of Engineering in Mechanical from Government Engineering College, Amravati. He joined Hindustan Aeronautics Limited, HAL Nashik. Further, he obtained MTech from IIT Roorkee and joined Birla Consultancy Services, BICS, a senior software engineer. Subsequently, he left the organization and joined VNIT in 1993. He obtained his PhD in 2001 from Nagpur University, now VNIT Nagpur. In his research focused on rapid prototyping, he used computer-aided design and specialized techniques of rapid prototyping and dedicated his efforts in harnessing this technology for practical use. The capabilities of rapid prototyping equipments were extensively exploited by him to make custom-built metallic implants which were implanted in human bodies by surgeons in several complicated medical cases, including the cases of cancers even. Further, the technology was also effectively used in engineering industry to develop zero-defect pattern making and casting. He has earned 2 patents for niche work undertaken by him. His contribution to national and international journals, presentation of papers at international conferences, and authoring several books demonstrates his expertise and authority on this subject. He was instrumental in creation of a well-equipped CAD/CAM center at VNIT Nagpur, which speaks volume of his passion for raising the bar of academic standards. His self-motivation for introduction of industry-oriented courses, guidance of several PhD and MTech students, as well as untiring efforts in creating awareness and building capacity for large-scale adoption of rapid prototyping using CAD is a testimony of his work. Thus, needless to say that Professor Madhusudan's all-encompassing contribution in the area of rapid prototyping goes beyond the conventional boundaries of industry and research. We are happy that he accepted our invitation and he is present among us and going to deliver the distinguished talk on 3D printing in design of innovative class C&D medical devices. With this brief introduction, I welcome Professor Madhusudan and invite him to deliver his talk and enlighten us. Professor Madhusudan, please.
Yeah. Am I audible?
Yes, you are audible.
Yeah. Thanks, Professor Dinesh Kumar, for the nice introduction. And though we could not meet physically, but
Yes.
even interaction virtually is also very nice. So thanks to IIT-DM for organizing such a wonderful workshop. And I'm quite impressed when I have seen the your something going on the YouTube where I can see your activity, even your department and all that. So it seems that I'm physically present there in IIT-DM now.
Yes.
Great. So thanks to Professor Prashant Jain and all the people, faculty members and the students those who are involved in the organizing of this wonderful workshop. So thanks for inviting me, and it will be my interest to rather in rather show you like what exactly this 3D printing has a role in the healthcare, especially when we talk about the Class C and Class D devices. So it's quite interesting for me to just enlighten you with what we people are doing, because I always used to say in many of my lectures to the even student also that I like the advertisement of ghadi detergent bar. They always say that pehle istemal karo and then vishwas karo. Exactly in the same way, I always used to interact with the audience with what we people are doing, and I think then they should evaluate us. Though nice introduction is been done by the Professor Dinesh Kumar. So should I share the screen now and start my presentation? I think I have the, yeah, I can hopefully in a position to, can you see my screen and maybe hopefully, yeah, can you see my first slide? Maybe in a presentation mode, I'm just taking it further.
Yes, sir.
Yeah, I think, yeah, can you see it in a presentation mode now?
Yes, sir, it is visible.
Oh, great, great, great. So title of my lecture is very big, but it is required because I have underlined certain words in the title. First is 3D printing, and then another very interesting word, which is a buzzword everywhere, is about the Atmanirbhar Bharat perspective. So what exactly the role of 3D printing in the design of the innovative medical devices? And that too, we are more interested, or rather, I'm more interested in discussing with you about the Class C and Class D medical devices. So, I'm presently working in Vishweshwar National Institute of Technology, Nagpur, as introduced by Professor Dinesh Kumar. I'm also the adjunct faculty of research at the DeM Institute of Medical Sciences, Wardha. And thanks to DeM Institute of Medical Sciences, that it is because of my association with them, it is possible for me to look into this medical domain. Otherwise, what engineer is doing in the medical domain, that's always a question many of my relatives ask. When you have completed your MBBS degree? I said, no, I'm not an MBBS doctor. Then they said that, how come that you are talking about the medical devices and all that everywhere? I said, yes, that's what exactly the ecosystem we need to build, and where the engineers and doctors should work together. Okay. So you can see the our campus, though it's a view from the front where you can see the our VNIT logo, and then ultimately the entry to main building, and it's around 300 acres, and it's a standing invitation to all of you to please do visit our campus and interact with me and see that we will have the close association in Sonwar. So this is the CARCAM Center about which Professor Dinesh Kumar has already talked about. And I'm happy to show you the two big boards which are hanging on the CARCAM Center related to the two mega projects that we are presently working on. The first one is the Biomedical Engineering and Technology Incubation Center. We call it as a BETIC, and another one is a Smart Foundry. Both are the multi-institutional, multidisciplinary projects having the total outlay of around say 49 crores together. So that's a wonderful rather the platform where we are now working on, and we do have the state-of-the-art machineries, but it will be quite interesting for me to discuss only the two that the FDM. I hope everybody is aware of nowadays. Even the students get the FDM in the hostels. That's what I came to know. And then the another interesting one is the 3D bioplotter. That is the logical extension of the 3D printing for the healthcare related purpose. So that's what exactly the 3D bioplotter. I'm really happy, or rather I'm proud to have such machine. That's the second installation in the India. The first one is in IIT Kharagpur, and then second one is in VNIT Nagpur. Later on, now many institutes like IIT Hyderabad and everybody is having the 3D bioplotter. So I would like to discuss with you on the interesting so-called the 4 topics. That's what I actually mentioned as an outline. Introduction, what is BETIC VNIT, and what is the startup success stories, especially when we talk about the Atmanirbhar Bharat, and finally the conclusion. I always give the more importance to the conclusion because there has to be some takeaway message after the end of the lecture, and that takeaway message should be the strong link with all of us together, and that's why the conclusion should not be looked as a conclusion that okay, it's now end of the lecture and then say bye bye, because this is a slot given to me is the pre-lunch slot, so naturally I'll have to see that how can I keep you well interested in my lecture. So the first one is about an introduction. Now, this is very well known that the need of the hour is to go for the innovative design, because as soon as we are entered into the liberalization, or as soon as we talk about the global market and allowing the advanced country to enter into our market, so naturally we had to go for the innovative product, innovative design, especially when we talk it from the design satisfying the client, or rather giving more and more comfort to the customer. So that's what innovative design. But along with that, the feasibility of manufacturing of the innovative product, that is also important. And that too, we need to rather look at from the industry 4.0 perspective, especially to which we call it the smart factory. So what exactly is the quick, rather the conclusion when we say that the innovative design and all that is, so we say that product should have the value, and that value talks about the comfort to the customer. And then the another one is the data. Data should lead to analytics, where you'll find that if we can analyze the data, it will be possible for us to get the zero defect part in first go. And that's what exactly the industry 4.0 talks about, or rather the emphasis more on the zero defect part. So these are the two things everyone should keep in their mind, that whenever we talk about the product, it should give more and more value to the customer. It should give more and more comfort to the customer. Rather, even if the customer is not ready to speak about what comfort he needs, we should be in a position to understand what exactly is the feature in my product should be, so that the customer, even if he is not aware, he will now enjoy the comfort. And then analytics is very important, and that's what exactly is happening. Now, application of the 3D printing in this particular scenario, I wish to rather discuss it from 3 R's. So the first one is related to the relevance. That why is it required? Do you really need the 3D printing? That's number one. Number two, resilience. Like once you implement that, once you say that yes, it is required, once you answer the question, then once implemented should not fail under any condition. Because all the new technology that we do or talk about, or rather we are always interested in, once it is implemented, that means the resources are already utilized. We have put a lot of not only the financial resources, but even the material resources and all that. So it should not fail under any condition. That's the resilience. And the third one is the responsibility. It is the organization's responsibility that it is committed towards the ethical and responsible activity. That means that the one who is actually demanding that yes, it is required, and he is saying that yes, I will take all the efforts to see that it is now installed or implemented, then it is not only the person who is rather taking lead in that, but it is the whole organization that it should be committed to that. So these 3 R's are very important, and I'm going to talk about application of 3D printing from these 3 R's. Okay, so let's look about the manufacturing industry. I hope everyone is now aware of, and that's what we are also discussing a lot, that there is to be innovation which will give the comfort to the customer. And that's what we talk about nowadays, about the research innovation. That means you have to innovate something. New and new research is definitely required to be carried out. What is the what exactly should be our focus? Our focus should be on the high-end knowledge and the research. And that's why, many times it happens that the people always take the research with a pinch of salt. And they say that why do we want research? Because we do have already all the things already set. But unless you enter into the unmet needs, you will not understand the value of the research. And there is a need of high knowledge and the research. That's what I always used to say. From the institutes in India, we do want UG students to come out, no doubt about that. But we do want more and more PG and PhD students, so that they will be the so-called torch bearers for the research innovation. That means what the manufacturing industry look at. What's the innovation? It's a tailor-made product. That means the satisfying to the customer. So can we think of that? Yes. The answer is somewhat difficult to look when you look at a traditional industry. And we do say that, oh, it's a big no for them. You can't think of innovative product or tailor-made product or changing even the product design often in the traditional industries, because they have been set up with the mass manufacturing perspective. Here, the only solution is the startup. So ultimately, everyone has to come to the startup. So I think this is very interesting for all of us to look at, that when we talk about any innovation or the comfort and all that, naturally we'll have to give more and more focus on the startup, and that startup related to the innovation. Okay. Interestingly, I would like to just discuss with you quickly about the interview that has been published of the Nandan Nilekani, to whom everybody knows, and he has been just asked a simple question, that what is the future of the India you look at? So that's what exactly in the Economic Times somewhere in the August 20 it has appeared, and I'm just writing it down for you so that you can read it very comfortably. He was just asked, like, you think the future for India will be where more small player also compete? He has answered it very nicely, saying that I am of the firm belief that it is not about few companies creating millions of jobs, but millions of companies creating a few jobs each. That's what I see as the future. I think it's a wonderful thing. If you read that particular sentences in the read text, I think it will be quite interesting for you to look at. There, what you'll find, he's saying the big companies, like, they can't create the millions of jobs. You can't expect that the L&T, Tata Motors, and everyone should create more and more jobs because there are more job seekers. It's not that. You have to see that millions of companies are created, and taking that research innovation into the consideration. And then ultimately, even if they create a few jobs, I think the job seekers, those who are actually interested in the job, they will be quite happy. That's what exactly is the case. Many times we hear, they say that be the job creator and not the job seeker. This is to be changed. You can't say like that. You should say that be the job creator, so that job seekers will be at ease, because job seekers will be always there. You can't say that the job seekers are not required and all that. Who will be doing the job which will be created? So ultimately, more and more job creation, and this is a wonderful thing. If you look at the economic survey of 2020 on the startup, I'm just tick marking that particular point there, which is related to the how many jobs are created. If you look at that, the jobs created is around 4,70,000 by more than 39,000 startups. So interesting. Think of whether such jobs, such a jobs really, of 4,70,000 will be possible for the big companies, or those who are actually working on a mass manufacturing engineering. Big no for that. So ultimately, it is the startup who will be always more creating more jobs, and that's what exactly the introductory part of my lecture. We need to focus on the innovation, and we need to focus on the startup. Okay, so let's go to the next point, which is quite interesting, like about the basic VNIT. That means what exactly we are doing in this particular domain for creating the infrastructure or the ecosystem where more and more startups are coming up, and at the same time the research is also being done in that direction. Okay, so if you look at this basic, I think, yeah, can I just, yeah, there is some problem. Can you see the, yeah. So now here, if you look at the basic infrastructure, this talks about the it's a R&D project, though it's not correct to call it as a research and development project, but we call it as a research and deployment project. Like in the D, we generally say that it should be bigger. So deployment talks about whatever the research we do, it should be deployed. It should be used in the society so that the common man will get the benefit. So here, when you look at this particular picture, this is a basic, and you can see that there are 3 institutes which are closely associated: College of Engineering Pune, IIT Bombay, and VNIT Nagpur. And we do have the philosophy of developing the medical devices by using the 4 steps. And that 4 steps are actually written there: define, develop, deliver, and ultimately the deploy. So when you look at these 4 steps, based on that, it is possible for us to design and develop the medical device, which is rather deployed, that which is actually used. So we do have the government, industry, academia, and hospitals together with whom we are interacting. Like, for example, clinical inputs, then what exactly the industry and hospitals are connected with the academia and government. I think that's wonderful. Okay. So when you talk about the government, we need to have the funding agencies, we need to have the standard regulations. When we talk about the hospitals, then with the clinical immersion, starting of that, clinical feedback, clinical trials, all this is required. When we talk about the industry, it is about a functional prototype, pilot batch production, scale up and market, all these things we need to interact. And finally, academia, which is very close to us, is that the how the innovation camps will be organized, what are the internship that we are creating, fellowship, product exhibition, and finally, whether it is possible for us to enter into the business innovation. So I'm happy to tell you that when you look at the institute network, so College of Engineering Pune and VNIT Nagpur, along with the Rumaiya College Mumbai and the DIMS Varda, all of them are the institute network. And when you talk about the products exhibition, we do have the project teams like the human resources to execute the whole structure. So when you look at this basic infrastructure, it talks about everything. Like, we are now closely knitted, and ultimately the goal is fixed, that the medical device is to be developed, which is deployed, which is used for the patients. So let's look at the medical devices in somewhat more detail. Now, I'm just giving you here some data, and that's what I mentioned. Let data speak. If you look at the medical devices imports in the last 5 years, then you'll see that the amount of money that is being invested, or rather that is being used to import medical devices, is continuously increasing. Though we don't have the official figure of 1920 or 2021, but yes, it is actually increasing, and I'm sure that it is definitely increasing in that. What is interesting here is to look at, when you look at the medical devices, then there are certain categories like electronics equipment, consumables, then IVD reagents, implants, disposable, surgical equipments. So here, when you look at that, you'll find that I am more interested in the implants. And that's what exactly I have already mentioned to you, that we will be rather more interested in looking at the Class C and Class D devices. Soon I will show you how exactly we do classify the medical devices. But implants are the devices which are implanted in the patient body, and that's a high risk one. And that's where exactly we are working on. And if we work in that particular domain, naturally we'll have to be more cautious, we have to be more careful. It is because we need to gain the confidence of the medical fraternity when we actually come out with the particular product. Another interesting point about the data, when we talk about the data, is about the look at the patent filing trends in Indian medical device sector. You will be surprised to note, if you can read the last line, text which I have mentioned there, the country-wise patent fillings in the medical devices sector from the 2005 to 2014, it's hardly changed. The pattern is hardly changed. The figure depicts the dominant IP fillings is about 80% of the total by the foreign applicant. That means the foreign applicants are actually filing the patent in India so that their devices will be used extensively. So what is interesting here is to see that there is a more push required from the Indian researchers to develop the Indian medical devices in the Indian medical sector. Okay, so let me show you here now the device classification. Hopefully that will be quite interesting for you to look at. Actually, there are the two classifications. The first one is about the class A, B, C, D, the way we generally classify in Indian context. But if you look at the international level, it is the class 1, class 2, and class 3. And therefore, generally, when we talk about the class C and the class D devices, as you can very easily see there, if you look at that table of where the classes and risk level and device examples are given, there you will find that the risk level is actually indicated in the subjective manner. Like we say low risk, then low moderate risk, moderate high risk, or the high risk. That means now when you talk about the class C and class D, hopefully it is the class 3 devices in international standard, where they say that it is a high risk product. That means you have to be very, very careful while designing and deployment of such devices. So now I hope the thing will be quite clear to all of you when you actually see the title of my lecture. It is related to the class 3 devices. And remember here, many times it happens that whosoever says that we are doing nice work, or if somebody says that yes, we are developing new devices and all that, I think the very first question we should ask whether you are working on a class 1, class 2, or class 3, or maybe class A, B, C, D, if he is not aware. But if he says that yes, I'm working on a devices like the one which you can say the class 1 or the class A and or class B, hopefully you say, okay, that's fine. It's what is definitely required, because that gives more comfort to the customer, patient. But important is that if we don't work in the class 3 devices or class C and D devices, I think we will not be meeting that requirement where we have already where I have shown you the concern that the imported devices is to be rather substituted by our indigenous devices. And that's what exactly the Atmanirbhar Bharat talks about. Okay. Now, as I already mentioned to you, I'll be more focusing attention on the metallic implants. And when you talk about the metallic standard implants, I think that particular figure you can very easily see. Thanks to Google Images, a lot of things is possible through that. But here, the hip implant and the knee implant, I think everybody is aware of. Even the bone screws, bone plates, spinal implants, though the shoulder joints and everything have been shown, but they are not even used extensively. But hip implant and knee implants are extensively used, and we need to rather, if at all develop such implants, metallic implants, then there is a stiff competition with manufacturing from the developed country, and that is one of the major issues. I hope this needs to be properly looked at. As I already mentioned to you earlier also, if there is a competition from the developed country, naturally we'll have to be very, very careful, because the medical fraternity has already developed the confidence in that particular product which is coming from the developed country. Now you are introducing them to something new. There you will find that the developing the confidence of medical fraternity in the product which is made in India, I think we'll have to take extra efforts, no doubt about it. And from that angle, what we have done in Betic VNIT, we have actually started with what is called the customization. We have actually focused our attention on the metallic customized implant. So, we start studying about what are the anatomical variation. That means why do we want to go for the personal metallic implant? Whether it can be made available and whether it can be rapidly fabricated. So let me quickly tell you our preliminary work that we have done. We have started with the hip implant, and if you look at the various parameters that is considered for the hip prosthesis, that's what is very much indicated even in the medical literature also, like vertical offset, horizontal offset, anterior offset, and even a neck angle. I think neck angle, neck shaft angle, as soon as I talk about the angle, I think we as an engineer start rather getting attracted towards that particular parameter. And exactly that's what we have done. We have taken we have actually studied the x-rays of around 220 patients in and around Nagpur. So we call it as a central India. And then we thought about like how the vertical offset or horizontal offsets or anterior offset and even a neck angle changes from patient to patient. I'm happy to tell you, though I don't show you the other data, but I'm happy to show you about the neck shaft angle and the number of patients. It's quite interesting. This is the data which we have gathered it here only. And there are 220 patients. You can see the variation in the neck shaft angle. It's from 140 to 124. And the variation and it is so scattered. It's not that you can say that, okay, I will be taking an average 130 or 132, and I'll say that I can manufacture that type of an implant, standard implant, mass manufacturing unit, everything is already set. So you can't do that, because that is also scattered. And what we need to rather develop the implant which fits the patient's anatomy best. That's what we talk about, the customization of the implant. So we have actually then seen that there is an interesting relation. I hope many of you people must be aware of, like the CT scan data. You can very easily exchange with the 3D printing. That is where the CT scan data talks about the slicing of the part or the organ virtually, and the same data you can use it in the form of a layer to build the medical part. So this is, I think, very interesting. And based on that, we have actually started our work from 2006 onward, when we have procured a machine. And then this is the interesting, rather the flow that we have seen and we have established also, like getting a data from the CT scan, converting into the STL file, various softwares I think you people must be aware of, like Mimics and Thematic and all that, and then getting the physical model of the PAL. So you can see here, I think I can just show you here by using the pointer option, so that it will be quite interesting for you to, yeah. So through the laser. So I think you can see that this is particularly an interesting part where you can see that you can get a femur model, exact model of the femur bone in ABS, and then you can use it by various manufacturing techniques, whichever you feel is more appropriate. We have used the casting, and this is the first part. I think again you can see at my pointer. There you will see that this particular part we have fabricated in VNIT in 2007, and we have shown to the people, medical fraternity, that this is the way by which it is possible for us to rather enter into the domain of customization. Because this particular femur that we have actually fabricated is the customized one, is related to the patient of which the CT scan is taken. And I'm happy to tell you that based on our work, we have been granted this particular project in 2009 by the Rajiv Gandhi Science and Technology Commission, which is development and testing of customized joint replacement implant using layer manufacturing. So this is the so-called cycle that I'm showing you here, though I don't want this cycle to complete, because I don't want a healthy individual to meet with an accident or he should become a patient. But if that is the case, in that case, you get a CT scan, and then using the CT scan, that data, you can get a medical imaging. Based on that, you can design your implant having the neck shaft angle and other parameters very much in tune with the patient's anatomy, and then use the rapid prototyping machine. Then we have used it as a pattern, use the casting simulation software, because we do want to set the parameters where we will be getting the perfect PAL. And then we have used the casting simulation software, thanks to Professor DeW for his AutoCAD software, which we have used. And then through the casting route, we have shown that, yes, it is possible to manufacture the customized metallic implant. And you know, you need it only one in number or two in number. Even that particular manufacturing is done, then ultimately in this surgery, important is about the regulations and other things, but it is customized. So therefore, patient's approval or the doctor's, rather the knee doctor's approval is only the two main parameters, and ultimately it is possible to clear that particular implant through the ethical committee of any hospital, and finally you can fit it into the patient's body, and he becomes an healthy individual. So that's what exactly we have seen. We have completed that till 2014. I'm happy to show you some of the interesting rather the case studies that we have done. The first one is about the customized implant that we have fitted into the patient's body for the temporomandibular joint. Now, don't worry, I'm sorry that there are some blood and other things shown, but I think you can see, at least as an engineer, the implant that we have fabricated. So this is an implant that we have fabricated, but I'm really happy to tell you that this is only possible because of the discussion with the doctors continuously. And you know, I always used to take some input from the doctor, like what type of the shape he wants, what type of the rather the structure he wants of that implant, so that there will not be any problem in the patient. So I'm happy to tell you that it was difficult for him to draw the drawing. You know, doctors not even write properly the text. So I'm asking him to draw something, and that too from the engineer's perspective. So it was difficult. So I just gave him the clay, and I told him, like, why don't you make this particular model? So he has made it a clay model. Then I have reverse engineered it. I got a rapid prototyping model. Then we have carried out a number of iterations to that design. Finally, this design is approved, which you can see here, and we have fitted into the patient body. And this complete case study is now published in Rapid Prototyping Journal, Volume 17, number 5, 2011. Please do refer that, because that's where we have shown that how it is possible for us to fit an implant into the patient body. And this is all possible because of the rapid prototyping. I think you can see these two interesting picture here. These are actually the models that we have got it of the deceased organ, and it is very much useful for the patient, for the doctors to execute what is called as the mock surgery. And because of that, everything went very nicely. So I'm happy to tell you that this we have fitted though the paper was written in 2011, finally it is accepted. But 2008, 7 and 8, that is December 7 and 8. Anyway, that's the time when we have fitted that particular implant into the patient body. I'm happy to tell you, even today, that girl, she was that time around 12 years. Now she got married, and now she has even a baby, and still she is okay. So, getting a feedback, we are in close contact with her, and she is really very happy with whatever you have done. That satisfaction that you get it. I think you can't get that satisfaction even if you get the PhD degree or developing any mathematical model and all that, because that's actually what we are serving the society. Okay, so that is one of the very nice case study, and that's what exactly our Betty philosophy talks about. Like whether you are deployed that particular model, research or not. Then the another one is customized metatarsopharyngeal joint implant. That is what we have labeled as the SAMQ. That SAMQ talks about the two people, those who are involved in the whole implant. The SAM talks about the Samir, Dr. Samir, who is involved, and KU talks about the Kuthe, that is me. So we have actually developed this joint. We have fitted into the patient body at the metatarsopharyngeal, where this is, if you can again look at the cursor, these are the things that we have actually designed based on the X-ray, and finally we got this particular implant. We have tested it on the diseased organ, and then we got this metallic implant. We have even actually carried out the stress analysis also of that, and finally fitted into the patient body. We do have a nice feedback of around 2 years for this particular patient, and everything is written in detail in the Rapid Prototyping Journal, volume 20, number 4, 2014. Please do refer that. You will enjoy that, how the design is to be done, how exactly the research is to be carried out, and finally how the research is to be deployed. Okay, so that's what exactly the another case study. This is again a wonderful case study about a malignant tumor that we have actually started working on. And then this on this particular case, which is actually available in the Journal of Maxillofacial Surgery, volume 71, number 2, 2013. It's very interesting because based on that, I think this is the first initiation where my researcher has started researching a lot on the medical implant, lot on the surgery, and lot on the how exactly the surgery is to be carried out so that the surgeon will be at ease. So the engineering input to the surgeons. So that's what exactly is very important. So what you will find here is that this particular design and ultimately the deployment of the implant, that's all very much available. Please do refer that. Now, what I'm going to show you here is the word no. And if you look at that particular word no, everywhere I written yes, 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 yes. What exactly that indicates? Metallic implant that we fit into the patient body, whether it is in the hip implant or whether it is the knee implant or whatever we people have already done. Now, it is always taken with a pinch of salt. Why? Because that is still today the gold standard. That means you can't say that, oh, the metallic implant is to be replaced by something else. Because in the literature, it is always indicated that bone is to be replaced by bone. That is so logical, so obvious. So here, when you talk about the metallic implant, which is the need of an hour, that's the only gold standard. But this metallic implant poses certain problems. And one of the major problems from the engineering perspective point of view, if you look at, it is the stress shielding. I think many of you may be aware of that, but I think at least those who are not aware, they should look into this particular field of stress shielding extensively. I'm just showing you here the photograph of a tennis player. Now, the hand with which he is holding the racket. If you take the X-rays of the bone of the hand holding the tennis racket and the hand which is not using the tennis racket, you can see, that's where exactly you can see even my cursor. You can see the very well developed bone of the hand holding the racket and not very well developed bone for the hand which is not holding the racket. It is because they say that when the bone is loaded, when the bone is actually is like exercised, then the bone will become strong. If you don't load the bone, then bone resorbs. Resorbs in the sense it losses. So bone loss is because of the resorption. That's what is because the bone is not loaded. And that's what exactly is the stress shielding. Because if you look at this particular picture, the metallic implant that we fit into the patient body, now you can see the one, so again to this cursor, that this titanium is fitted into the patient body, and there is a cancerous bone, cortical bone, and all that. So, the load that get transmitted from the upper body to the feet, most of that is taken by the metal. And then the cancerous bones and cortical bone, they are not loaded. In such scenario, what will happen? In due course of time, they will start resorbing. And if they start resorbing, then resorb. The resorbing leads to implant loosening. And that's what exactly you can see it here. So this is what is an implant, where you can see that the bone is resorbing here. Okay, it's not getting developed. So ultimately what happened? That this implant become loose. And once this implant become loose, then that becomes a major problem, because you have to go for the revision surgery, which is more problematic, it's more critical. So what is important here is then what is the solution? Solution, as it is indicated here, there are n number of solutions by which this particular problem can be addressed. Even the 3D printing of the implant, that also comes out to be the one of the solution. But there is another interesting thing is about the scaffold development, where we enter into the world called tissue engineering. Can you develop a scaffold and then put it into the patient body? The answer to that is yes. And that's what exactly, this is a 3D bioplotter which we use extensively in our CAD/CAM center, where we actually fabricate the scaffold, where the scaffold is fitted into the bone, and then the bony structure will start getting developed. That is, the bone tissue will start getting developed. So that's what exactly the area. I can quickly show you here the bone tissue engineering that we are now presently practicing. Though the stem cells and other things we are now slowly not involving, because that itself is another problem. We are only focusing on the scaffold fabrication. And this scaffold fabrication, if you fit it in, that means if you fit the in the patient the scaffold, then ultimately slowly the bone will start developing in the scaffold. The research is still required to be carried out, where the scaffold will slowly start degenerating, and then ultimately the implant made of the bone is possible. So that's what exactly the area of research where we are now presently working. Now, again, look at the Batic VNIT from the 3 R's. We say that relevance. What is the relevance? The relevance, why it is required, because import substitute implant is the name. Then customized implant, that's where exactly. And now the startup ecosystem in class C and class D medical devices. I hope the thing is quite clear to you. Then what is the resilience? Once implemented should not fail under any condition. Yes. What is our Batic philosophy? Define, develop, deliver, and deploy. And we will be focusing more on TRL 5 to TRL 9. It's not only the TRL 1 to TRL 5. I hope the technology readiness level, and you'll find out how the technology readiness level is defined. So 5 to 9 talks about once your prototype is ready, once your model is ready, working model is ready, how to market it. That 5 to 9 is the most difficult thing, and that's where we are focusing. And we are now developing the confidence of medical fraternity, because in our philosophy of Batic, we start from the clinical immersion, that is from the defined stage, where we take the doctor into confidence, and his advice, or based on his advice, we only execute our research. It's not that we are doing some research and all of a sudden we are showing it to the doctors that this is what I have done for you. He will then may accept or may not accept. Why not involve him right from the first stage? So that's what resilience. And finally, the responsibility. That what exactly we do want. We do want a strong linkage of medical and engineering. And that's what I already mentioned to you earlier, that I'm closely associated with the DM Institute of Medical College and Medical Institute, where the doctors are closely interacting with me. We are now very much involved in the Batic VNIT, and hopefully I will be in a position to show you quickly in the presentation itself. So then now let's enter into the startup success story. Especially the interesting part in our lecture is about what exactly the startup success story is about. So here I had just mentioned it like what is the startup success, or what is this Atmanirbhar Bharat talks about in the medical domain. So here, if you focused on a customized implant, then that is what we have said, unmet needs. So you have to always see that you have to find out what is an unmet need. So if you can see that, then that will be quite interesting for you to enter in that particular domain, because that's where exactly the research is required. And I have already shown you some case studies that I have already done. Now, these unmet needs help us in actually entering into the very nice, rather the, the field where we are always thinking about TRL 5 to 9 is okay. But what about TRL 1 to TRL 5? There, you also need more and more inputs, more and more resources, whether such resources are available, whether you can get some resources. So I'm happy to tell you that the Biotechnology Industry Research and Assistance Council, they provide such grant that is called a big grant. They call it as the ignition biotechnology ignition grant. I'm happy to tell you that this big grant, which is having the amount of around 50 lakhs, then that is for a period of 18 months. And they support your approach from TRL 1 to TRL 5. Once your TRL 5 is ready, then there are good number of grants available. But then investors will also start entering into your domain, because you have proved that the model is successful. I'm happy to tell you, 3 of my researchers, they have started their company based on the big grant that they have won. And the 2, Dr. Sandeep and Neha, they are the big grantee. They have started the company, CU Precision Limited by Sandeep, the OCO Eye Care Solutions Private Limited by Neha. And happy to tell you, Dr. Pranav, he has won the IIGP 2.0 award, and he has also won many rather the grants or the support from the private investors also, and he has started the DuPD plants. So all 3 of them, they have worked as a researcher in our Betik Benati. Dr. Sandeep and Dr. Pranav, they have actually completed their PhD under me, and whatever the topic they have actually taken during their PhD, the same they have continued in the rather their company or as an entrepreneur. Now I'm just running here the small clip, which is only for 2 or 3 minutes, not more than that. Okay, I'll just like to see that. 1 minute. I'm just getting the point. Right. Yeah. So I'm just running the video clip. Maybe it's only for 3 minutes. Only thing is that I'll have to only tell me whether you can hear the voice. Okay. That will be continued only for 2-3 minutes. Okay. I'm just running it. Can you hear this? Can you hear the voice? Hello.
Yes, sir. You are audible.
Nice. Okay. Nice.
No, sir.
The video sound is not available.
So you're not
Video.
audible.
Okay. I think video sound is not available. Okay.
Yes.
I think some setting is required to be done, but I don't know. Let me see if I can check with the sharing.
So can you stop sharing and share it again with the audio?
Oh yeah. That's what actually I'm doing. That's what exactly I'm doing. I would like to just go back. I will stop sharing here. Okay, and then hopefully that should work. Yeah, should I do any changes here to see that? I think in the share screen, in the share screen option.
While sharing the screen, there is an option to allow audio. Tick that option, and you should be able to
share the screen. Okay, and then no. Before that,
is there an option asking you to share audio before share screen?
Before sharing, no? Okay, so I'll again stop sharing.
So, can you play the video first and then share your screen?
Okay. I'll just do that. Let's see if that works. Because I think there is some I think here there is something to be done. I don't know whether that works. Hopefully I will first play the video and then I will play that. Okay. Then I will share. Okay. That should
Yes,
should I do that? Okay.
Yes, sir.
Okay.
Okay. I'll do that. 1 minute. I'm just playing the video now and then sharing the option. Okay. I got somewhere lost since then. I'm sorry that I got lost somewhere. Hello, am I audible? Yeah.
Yes, yes, you are audible.
Yeah. And then maybe I think I can now show you. I can't see now the sharing option. I think let me then, somewhere I got lost. I don't know how comes that it's not.
So, is there an option to share screen?
No, it's a launch meeting. That's what is actually coming. I think.
No.
But you are still live, sir.
I'm still live. That's why I think I somewhere I lost that. Maybe I think this is the.
So, can you share the file to us so we can play it?
Okay. I think I can do that later on. No issue about it. But let me quickly tell you about that. I think, can you see my screen now? Hopefully, yes or no? Because the sharing screen option is lost somewhere. Okay, what I'll do, I'll just quickly, hopefully with this, it may help because I'm just taking it back, but not happening. I don't know. Something has come just which we should have done it earlier. What I'll do, I'll just switch it off and then come back, join it again here. That will be quite okay. Maybe I think that way, because I'm still connected, unable to see that how. Yeah. Now I got it. I'm yeah, sure. So I think you can see my screen now. No, it's not this. No. I'll just sharing now.
Please share it.
Yeah, I think then I'll have to share my.
Yeah.
Load my.
Can share the screen.
But PPT also just got lost and all that. Some teaching problem somewhere it always happens. I'm happy to tell you that this is. I always used to feel that yes, it happens only in our institute or in some other institute. But when I delivered the address in Harvard University in 2011, there also they faced the same problem. I said then okay, even there also scenario is the same. So anyhow, let me see if I can run the video till the time the this gets loaded, and maybe if you can see that. So yes, sharing, screen sharing, yeah. So I think with that, hopefully if it works, then yeah. Can you hear that? Can you hear that?
No, sir. Unmute karo.
No,
sir.
Sorry. I think I will share it with you.
Video, then share your screen.
Okay. Should I do that then? Okay. Then maybe I can.
Camera.
Anything. I think we are now. Maybe I can send you the video. That's not a big issue. So, but let me let me now finish up with our text part because that is more important. As I already mentioned to you, it is more important for me to see that I can discuss with you about the so-called conclusion part. That is more important.
Yes.
Yeah, I think you can see my at least the PPT.
Yes, yes, it is visible now.
Yeah, sure. Let me take it to the slide which I was showing. Yeah, I think you can see that slide also. I think I'll share with you of the video file. Actually, it indicates like how these people have started their career in the research as a PhD students, and ultimately how they have entered into the this particular startup arena. Okay, so I would like to tell you that the one of the interesting thing about the Dr. Sandeep is about the predecessor. I think you can visit on the website these three interesting startup. So he has developed a very nice product where he is actually designed a surgical guide for the surgeon, that whenever a complex surgery is required to be executed, where the resection of the part is done, like for example in the cancer surgery, head and neck surgery in mandible, so you can fix up that how where exactly the part is to be resected. I think you can see, if you see my cursor, that these are the slots which are provided where the surgeon can use the scalpel, cut the part, and finally the implant can be properly fitted. Otherwise, if the implant doesn't get properly fitted, remember here, that's very important, then there will be some stresses and ultimately the failure and the implant is bound to happen. So all these things you can avoid if you have a very nice surgical guide available, and he has developed a flexible surgical guide which can be used for any surgery. So that's something very interesting work he has done. Even this Pranav has actually developed the scaffold for the tissue engineering, and he is actually marketing it. So please do visit the Lupid implants and website. And the Neha has developed a device for detecting the glaucoma. So without rather the any anesthesia, that's by closing the eyelids. So these are all the things these people have done. I'm happy to share with you that the Sandeep has actually won the Mimic Innovation Award 2020 of around €1,000, and he was the second in the world. The first is the Australian, another one is the Sandeep. So I'm happy to tell you that this is how these people have started working on. And I'm also happy to tell you today itself, like yesterday, I received the mail from him that he has received now Nidhi Prayas grant also of 10 lakhs. So he was a big grantee. Now he is having a Nidhi Prayas grant also. And this is from the signed IIT Bombay. What I would like to tell you is that your product is getting evaluated by the more and more funding agency. That itself speaks of the success of your product. So that's what exactly is the need of an hour. And this is what exactly I would like to rather focus your attention on, that we need to enter into the class C devices, D devices, or class 3 devices. And ultimately there is a need which we need, which is not met. But if you enter into that domain, medical fraternity will also help us. And the what actually is the important word in the title, I think you can look at the Atmanirbhar Bharat. So we have actually arranged an online symposium long back in March. This is available on the YouTube. You can very easily see that. And the theme is engineer your research for startup. I think that engineer word, I have used it as a verb. That means you have to rather mold your research in such a way that you should be in a position to start your own company. So I wish to see the day where the number of, if somebody says that in our institutes that we have offered suppose 10 PhDs or maybe 100 PhDs, doesn't matter, because the one year I have seen in VNIT, we have offered the 100 PhDs. Then I wish to see that there are 100, at least 10% of that, the startup is there. That means we shall say that 100 PhDs, 10 have started their own company based on that research. I think, and maybe the wish list, you can always take it to any level. And I should say that 100 PhDs or 10 PhDs in from our institute and 10 startups based on that particular research. That's what exactly we are supposed to look at. So this is a theme on which we will be presently working on. I'm happy to tell you about our Betik VNIT, and that's what exactly is the last part of my presentation, the conclusion, which I always used to say that this is more important for me, and what is necessary, that conclusion should not be very problematic to understand. It should be very simple. And we always used to say that the picture is worth 1,000 words. So exactly in the same way, I'm just showing you here the nice picture where you can see our Betic VNIT as a team, where we are now rather asking the students and innovators to please do come and work with us, so that they are like birds coming to our Betic VNIT tree. So they will help us to start the startup where the innovative medical devices will be developed, which are nothing but the fruits. And I wish to show there the very interesting thing, that the Atmanirbhar Bharat ladder. Through that, if you can go and pick up that fruit, I think that's what exactly the happy society looks here. And everything is possible. Everything is possible because of the sun, as everybody knows, and that's what Betik IITB we do have. So what I would like to tell you here is that this explains everything. And this Atmanirbhar Bharat ladder is important. Why? Because when you are actually developing an innovative medical devices, now the medical fraternity should accept it. Medical fraternity should support it. And then they should, oh, no, I will be using the Make in India product. And that's what one of my close colleague, orthopedic surgeon, he always used to tell me, Professor Kuthe, I would like to see a day when the orthopedic surgeon will demand the Indian implant rather than the imported implant. He will say, no, I want Make in India implant, maybe the hip implant, knee implant, whichever the implant he is interested in. So let me show you another interesting picture here about the conclusion. Only 2 points. Startup as a technology-led innovation. This is very important. Now, some innovative idea has come, and that will actually help us in starting the company and all that. I don't support that. I should say that please do the research. Please take it as a research topic, maybe at the MTech level, maybe at the PhD level. That means now you are thoroughly working on that. Then think of how you can mold it for the startup. I think that's what exactly our startup focus should be. And another interesting point, sustainability oriented innovation. That means it should not happen that, okay, the innovation is done and then it is not sustaining. Some new innovation is coming, and that is our innovation is now getting obsolete. That should not happen. And in that particular area, bionics works as a very interesting field. All of you people can go to the Google and look at that. They're imitating the nature in developing the product. So that's another interesting point. So I'm just showing you here through this sketch that what exactly we are interested in. The research which is leading to patent granted, maybe the PhD, MTech, whatever it is. So if you can get a patent granted, that doesn't mean that only the PhD student should do the startup and all that. Even a BTech student, if he has a wonderful idea where he has actually done some research, and then if he can grant a patent, then that can be deployed.
Excuse me,
as a startup.
sir.
Yes, hello.
So sorry to disturb you, but we've been like overshooting the time. So
Yeah, yeah, no
yeah.
problem.
Just within 2 minutes.
Yes,
This is the last one.
no problem. Professor, please take a couple of minutes more. There is no problem.
This is a conclusion part only. Okay, it's a conclusion.
No problem. Yes,
okay.
it is just.
So, yeah, what I would like to tell you here is that this patent, if you have granted, even if you are filed, think of its deployment as a startup. And if at all you have done a PhD on a particular research, then definitely think of as a startup, maybe through the postdoc and all that. And that is what we are aiming at. In this CAD/CAM center, you can see the floor that we are now built. So here you'll see that this Betic VNIT floor is very interesting, where we are actually developing such type of an ecosystem. And there you'll find that we are asking the PhD students to work with us for the 6 months as a postdoc, so that we can help them to get the grants like a Bioreactic and all that, so that they will start their own company. That's what exactly is. So, it's a fire in the belly. That's what we always used to say. Now, when you talk about the fire in the belly, what exactly it is? And interesting, the cartoon I have seen in Economic Times. I hope you can see that. The two people are talking, and the person who is having a very nice job through the IIM and all that, he said that the day I was to join your revolution, I got a call later from IIM, and therefore I am not interested in joining your revolution. That's not the fire in the belly. Once you enter into this particular domain of startup, so don't worry about what type of the jobs are available, whether you get the better job later on and all that. No, once you enter into startup, that's what we talk about the fire in the belly. Whatever comes in between, the people will do. People should work in that, and that's what exactly is happening. So, and that's what we do want, that such ecosystem should be developed in each and every institute, higher learning institute. So, thank you very much for your patience hearing. Sorry for some interruption in between to not to show you the video, but I'll pass on the videos to you. And my email address is amkme2002@yahoo.com. Okay.
So thank you so much, Professor Madhusudan, for your
Yeah.
highly stimulating and illuminating talk. Really, really so motivating it was. In fact, after hearing your talk, we feel like switching our research field. Though we work in different field, but we feel like switching our field to this medical devices like CLD. You have emphasized. Really, it is the need of the hour. What you have mentioned about, and I'm sure that it was so inspiring. It may be inspiring to the audience also. So now this is the session is open for a couple of questions. If some audience, they would like to interact, they would like to ask a couple of questions because we have the time limitation also. If a couple of questions are welcome.
Or maybe, sir, they can pass it on to my email.
Okay,
I
sure.
think I can because we are already exceeding the time.
Yes. We have the time constraints. So thank you very much, sir. Thank you so much for your sparing your valuable time and giving this illuminating lectures. Thank you.
Thank you, sir.
Thank you.
So should I leave the meeting now?
So can we take a few questions?
This is what I'm saying.
I'm ready. I'm ready.
Yeah. We can take few questions. This is what I'm saying.
Okay, sir. Yeah. So class D medical devices are highly risky. What kind of challenges would arrive in the deploy stage of the BETIC model?
What? No, I'm not understood the last one.
Okay.
What?
Class D medical devices are highly risky. What kind of challenges would arrive in the deploy stage of BETIC model?
Oh, it's a wonderful question. I think it will be quite interesting for me to discuss with him in person also, or maybe through the email mode. There are a lot of challenges, no doubt about it. Because see, ultimately, let me tell you quickly what exactly the question that is asked to me when I have presented one of the case studies in Harvard. They say that you have implanted the metallic implant in the patient body. What you would have done if the same implant is to be fitted in your body? What would have been your reaction? I was a bit unable to answer that question. I said, yes, I never thought about it. Because, see, you are fitting into the patient body, patient is doing right and all that. Everything is in the patient body. Why should you worry about that as a researcher? But this is what is the major challenge. Like in case of a cancer patient where we have fitted, there are always the issue. Like if you operate the patient will die. If you do not operate the patient will die. What should you do now? Should you operate that or not? That's what exactly we need to take the decision, because that's what the cancer patient and what that too in a terminally ill patient. So what I would like to tell you, such challenges are always there. But remember one thing, that when you actually enter into the customization, I think your challenge, the biggest challenge, is to convince the medical fraternity that yes, this is workable. You are using the good manufacturing practices to get this particular implant. You can show them that how you are using the simulation software and execute getting your whole manufacturing done. The material that you are using, how perfect that material is and all that. I think if you can develop the confidence of the medical fraternity, it is as good as getting the confidence of the patient, because it's a customized one. So patient will always ask the doctor, Doctor Sahab, aap batao, kaun sa baitha na ki nahi baitha na bhai? Because see, ultimately he is a layman for all these things. And if you can convince the medical fraternity about the devices which you are innovating and deploying, I think the major challenge is to convince the medical fraternity. I think if you can do that, I think everything is smooth. Everything is very easy. Hope I answered that. Maybe I don't know, because there are a lot of things to discuss on this issue. Yeah, sure.
Yeah. Any other query? So Dr. Parveer is present?
Yes.
Yes, sir. You have some query, please. Yeah.
No, I don't have any query.
Okay, you don't have any query.
Great.
Yeah.
Thank you, sir. Please send your email ID, the people
Yeah.
the video to us and the
email. Sure. I'm just typing the
share to all participants.
I'm just typing the email ID here. I think you can see that it's for all. So you can send I think hopefully everyone can see on the chat box my email ID. So just amkme2002@yahoo.com. Please do send your queries to that. And it's not only the interaction to the email, but whenever you get time, please do visit our CAD/CAM center. Maybe I think I can pass on this responsibility to the Dinesh sir, so that he can take people there in our CAD/CAM center and see that. And I think Prashant is a very good friend of mine. I think
I can understand. Yeah,
yeah,
I can understand. Yeah.
Okay.
So when there is no query further, then let us thank Professor Madhusudan once again. Thank you so much, sir, for sparing your valuable time.
Okay.
And now, so this is the end of the first session, and the second session will start after the lunch break.
Okay. So can I leave the system now? Can I leave the meeting now? Can I leave the meeting?
Please.
Thank you.
Please.
Thank you.
Okay.
Thank you, sir. I'm sure the participants will be excited to contact you for more information. Thank you, Professor Abhay Kumar and Professor Dinesh Kumar V. And thank you both for the wonderful session. The session has now come to an end. As sir said, we'll be continuing after lunch break at 2 p.m. Please join us back soon on the same link. Thank you.
Okay, thank you. Bye-bye.
something. My heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'll be fine by tomorrow. Oh mama, oh yeah. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'll be fine by tomorrow. Oh mama, oh yeah. Oh mama, oh yeah. and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Whoa, mama, oh, yeah. The queen of love promised me that I'd be fine by tomorrow. Whoa, mama, oh, yeah. Acting like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. 'Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Oh mama, oh yeah. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Whoa, mama, oh, yeah. The queen of love promised me that I'll be fine by tomorrow. Whoa, mama, oh, yeah. Whoa, mama, oh, yeah.
Camera.
Good afternoon to one and all. Welcome to the second session of DeW 8.0. Let us dive into some interesting applications of design thinking in the healthcare sector. I would now like to invite Dr. Praveen Mukhopadhyay, the head of design discipline, to please introduce the session speaker. Over to you, sir.
Good afternoon, all of you, and a warm welcome to this session. Our speaker today is Mr. Sudhir Kumar, and I take the pleasure of introducing you to Mr. Sudhir Kumar. So Mr. Sudhir Kumar is an alumnus of the famous National Institute of Design, Ahmedabad. Today he is the director of SKM Designs. Mr. Kumar has steered his design services into research-related fields of healthcare, where he has to his credit 60+ professional diagnostic and therapeutic medical devices design and development. These medical devices have been taken up for manufacture by large, small, and medium enterprises. His clients, they speak highly of the competitive benefits of their organization have gained through investment in design and vouch for Sudhir's contribution in the success story. Sudhir is also the recipient of the Hindi Hitachi Scholarship in Product Design offered by the Japanese giant company Hitachi Limited, Tokyo. This offered him an opportunity to undergo a 6 months training in advanced studies in product design at DeW, Hitachi's home appliances center in Japan. This exposure proved influential to help focus on design and development of medical equipment. Ladies and gentlemen, please join me in welcoming Mr. Sudhir Kumar for his talk. Mr. Sudhir Kumar, I welcome you to please start. Thank you.
Yeah, hi. Oh, sorry. Thanks, Dr. Prabir. Hi, I'm Sudhir Kumar here. And first of all, thanks to IIIT and thanks to Dr. Prabir for giving me this opportunity to discuss about my work, real life work in, especially in the medical sector, because, you know, we as a company have done several kind of a product in different domains. And medical is one thing which is a very personal to me. And since I think 2005, I have been really involved in really helping out the MSMEs who are like not so accessible. I mean, the design is not so accessible to them. And me as a designer have really had to help them out. And let me share my screen here because I have a long PPT and I really want to show the work and then discuss and the real life experience. So once again, I'll just. I'm unable to share. 1 second. Yeah, 1 second. I just got it. Is my screen visible?
Yes, sir.
Okay, good, thank you. So the topic given to me is like real life application of design thinking in healthcare. And this is the first session I have. I have 2 more sessions. I have done my mechanical engineering, 1988 to 92, 4 years. And then product design from NID, Ahmedabad, that was in 1993 or 96. Okay. So if I talk about my capability as an engineer to design a product, that was very limited. And when I really joined NID, that gave me another further wings to look into the product from different perspective and gave me more kind of a capability to design any kind of product that we can. So I have personal liking in variety of variety of industry verticals, and I've really chosen medical as one, engineering, and then we have the renewable energy, home appliances, and more. Okay. So today we work on, as a company, we work on almost like 7 different industry verticals, and our products have been winning awards, both domestic and international, and really getting a lot of recognition. Most important, like the products are really giving a lot of good business to the client whom we have designed the products. So I personally have done about, say, 300 plus products and as professional projects for the industry since I started my company way back in 2005, and about 70 products in healthcare. Okay. And currently we are in line of several of them as of now, because we are going to do again a large range of products we're discussing. And we have done like medical diagnostics and therapeutic products. Okay. Mostly, if you talk about like our capability in terms of what did we do in a product design, we actually have a lot of like form development. Like if your technology something is given, if we talk about this microscope, which is what you see is here. I mean, we as a designers are not supposed to touch or we alter the optical path of that microscope, but we are supposed to do the kind of aesthetic person. So this is like something which is form design, but again, there's another aspect is like concept to working with prototype. When you start with something new, fresh, and I'll discuss both of them. So this is really interesting to know that how this design can really make a big change in the industry. Okay. And talking about this Hindu Hitachi scholarship, this really given me a lot of a lot of capability. If any of you want to try that, every year 3 engineers or designers, they are selected by Hindu group and Hindu and Hitachi group, and they go to Japan for 6 months of advanced training, not necessarily only in design, but they can go to for any kind of any engineering sector or telecommunication or powers. Or Hitachi is a big giant company in Japan, and you may get an opportunity to get trained there. Okay. And I was in Tokyo, and almost about 6 months I was there in Tokyo, 1998, and this was the kind of a Yokohama training center. When the first 6 weeks we were actually put in there, and we were taught the Japanese language. So I know a bit of language. It's been it's almost like 25 years now. I really have forgotten most of the things, but I think I remember the kind of experience we had in 6 weeks of advanced training, 6 weeks of really good language training in Japan, and that was really people from different countries, and we were there from India, 3 of us. And the kind of we at the end of the kind of a project with the Hitachi, I was offered this 2 certificates, one from AOTS, like an Advanced Overseas Technical Studies, and one is from the Hitachi Limited for the design of a vacuum cleaner, which I did for them. A very original design, and almost 4.5 months with Hitachi and 6 weeks for the advanced training, in the language training. So this experience was really good. I would for kind of 6 month exposure is not only kind of you visited Hitachi, but you along with the Hitachi, we were taken to many kind of other Japanese company like Mitsubishi and Honda and other companies who get an industrial exposure. So the kind of learning I get from Hitachi is like really a practical approach to design and development. Because at times we end up doing a very hypothetical product, whether it works or not, but it doesn't matter. But now Hitachi taught us really take into account the kind of practicalities, a sense of confidence to handle any complex products. Okay, so it's like whether it's a simple or complex, you have the confidence to handle any kind of a situation and a problem, and a teamwork. Most important, because design alone is like not everything. You alone can't do anything much. You have to have a team, and that what it taught us to work in a group as a team and pulling kind of expertise what people have and likewise. Okay, so as a kind of a product designer and a mechanical engineer, I am able to really utilize best of my kind of knowledge and talent and experience to design kind of any product I do as in today. So this was really good experience. Thanks to Japan for giving me this opportunity. So this is my topic about coming to my topic, real life experience application of design in healthcare. If you really talk about this figure here, the market size is expected to grow by to reach 50 billion by 2025. It's a lot of scope in kind of designing medical healthcare products, and really this encourages us to really specialize in the domain and really do a good work for them, because medical is really rising and one need to really give time to that. Okay, and yeah, these are the companies that we as a company has worked for. I think Medtronic, we worked for 2015, only one project we did, but that was very significant, a kidney dialysis machine. I'll show you that. BPL Medical Technologies, again, large size company, SMEs. We have the DRDO lab. Important is like, DRDO, they have the life sciences division. And these life sciences division develop several kind of product related to human being. Okay, some of them are like, something with toxicology, some work with the body physiology. Only thing, the kind of research outcome is not always so kind of impressive. They really deal with the technology aspect. But when we as a designer can really pull our hands together, the product really take a shape. Okay, DeW is a company based in Mumbai that's doing a large variety of kind of lab equipments, all related to health. I mean, you have the blood bank refrigerators, or you have the shaker incubator, or you have the blood centrifuge. So many kind of variety of them, but all of them are like really good looking. I'll show you the kind of initial and the final and what kind of approach design thinking has really gone into that. Shivani, RMS, Lebomed. Lebomed is a really classic example when I have done all the product with them. I think since last 20 years, I've been associated with them, and their products are really winning red dots. Okay? Because not all the companies apply for red dots, and because it's really expensive, the application fee is high, but they have applied 3 times and they've got all 3 kind of awards. PHFI is one of the NGOs based in Delhi, and Shuddha Healthcare and BIRAC. BIRAC is one thing. One of my clients has got is funding from BIRAC, and we are engaged with them for last, I think, 2 years to develop a physiotherapy device, which is really a very good achievement. Almost like 50 lakh grant was given to us. So these are like broadly. Apart from that, we have many small companies and many smaller MSMEs and tiny companies who we are associated with. So if you talk about like a design thinking, especially in the healthcare, we need to understand what are the kind of component of it. So better understand the unmet need of the people we are creating for. We need to understand the customer. We need to understand the client, student, user. And client is really important because I have a talent. Of course, I have a talent, but when client has some sort of a kind of resources available. If you don't understand the client, you won't be able to do a good design. Because you may be having a very good, crazy idea, but to translate that into something meaningful and practical, this is what is needed. You need to understand the customer whom you are going to design it. Okay, reduce the risk associated with launching new product and services. Okay. So, we take a practical approach. We just when we working with the industry, we are very sure that we have a time limit, and we have to come up with an idea that we are able to translate into something much more meaningful, something practical, something MSME or SME is able to apply that, or maybe launch into their product line. So we need to understand, be very practical in that. Generate a solution that are revolutionary, not just incremental. We're not going to just do cosmetic changes here, no. Because most of the SMEs and MSMEs will have a sort of thing which are like very primitive. So if you talk about the internal hardware mechanism, if you talk about the use of electronics, if you talk about the use of other kind of connected devices, they are like really, most of them at times they are like really primitive, and you have to work on that to use the latest component what we have in the market, and then make their product really good. Learn and iterate faster, because design something is like really very iterative. It's like at times we fail, and we need to learn from a failure, and we need to iterate. We need to iterate till we have really achieved the kind of perfection. You have done a very good design, but at the same time, what happened? The cost has gone really up. So can you really iterate it again to bring the cost down and make it practical? Because at the end of it, the viability is like a real factor. You're not going to ignore that. So products should be viable, should be going to fetch a kind of a profit to the customer. Otherwise, it won't stand in the market. So design thinking applications are like you talk about any kind of a sector, any kind of a business, government, education, or a non-profit. Design thinking can help us develop innovative solution based on the need of the customers. We as a designer are going to intervene anywhere. And really the kind of experience I have in a variety of customers which I have worked, I've really applied the design thinking to different places. Not all the places things are all same. But I need to understand the need first. I need to understand what they want actually. I need to understand the kind of the kind of a market that is going to really emerge, and the kind of the product that is needed for the upcoming market. Okay. So this real example from different industry vertical I'll be showing in my slides here. And there are several good case studies. Okay. And these case studies are really good because you at times kind of the company, they have a mindset. Okay. They really don't want to deviate from their original design, and really we have a very strong dialogue, and we need to understand. We need to convince them. You see, if we don't really change at this point of time, somebody else will do, really take a kind of lead, and then you'll be lagging behind. So you need to be with them. They need to understand design is some person, expert from outside. And if he says something, we need to, the MSP need to take it more seriously. So these are very, theoretical part of the design thinking process phases. And at times, like it seems to be linear, but it's not always linear. like, it's a lot need-based that we understand the client, understand the kind of need, understand what we need to deliver, and based that we can slightly tweak the kind of phases, right? So these are like, if you talk about the very linear phase, frame a question, gather inspiration, generate ideas, make ideas tangible, test to learn or share the story. Okay, these are very standard procedure, or kind of a very linear process to understand what the design thinking is like. But I think we need to slightly tweak based on the kind of need that we do. And ways to get started with the design thinking is like gather insight by practicing empathy, observation, and interview. Because you need to understand the product. You need to understand the problem first. And this is what you're going to observe it, because you as a designer are going to observe it. Nobody else can do, because the kind of the expertise you have, the kind of experience you have, and the kind of eye for detail you have, nobody else will. Okay, so you need to know your customers. Okay, there's the first step towards the kind of creating a product and services they want to need. Okay, and let's not assume things here, because we need to work around a certain kind of a boundary, and we need to be really very practical. Again, when I talk about the services, one need to be really, really practical. Okay, you can really blow your mind. You can go out of the box. You can go out of the boundary. But at the end of the day, you again go back, go within the kind of boundary and show your talent here that you really solve the problem within a given constraints. Okay, building scrappy prototypes to learn about unmet needs. At times we we do prototypes, okay, because we are given like a set of kind of problems and we are not very sure. So it's like, initially we make a very, but what you call as a POCs. So if someone say that, okay, let's do this kind of a thing, we convert that, his need into a 3 or 4 small sort of a POCs. When we test it, whether the client want a sort of thing that is practical or not. Okay, so this is kind of a quick prototype that helps in understanding the product and the need. Okay, turn the problem into a questions. Okay? And the use research to understand the past, present, and the future. So these are like 3 or 4 points which we use occasionally, and at times need base, and then we kind of get a data to get started with. So generally the kind of research we do is like we have the generative research, evaluative research, and validating research, because validating is really important, because whatever you're going to really come up with is going to get validated. And the first one, like generative research, helps in identifying the new opportunities and explore needs. Okay, and evaluating those research, gather feedback on experiments, and helps us to iterate forward. The top 2 research are going to focus on the future of the future and the new ideas, because if you are really developing these ideas, you need to really see that whether you have met these kind of research, you have done this research correctly or not. Validating is important, is intended to understand what is currently happening. Okay, and if you have really done the 3 research, you're going to come with a really good kind of understanding of the product and understanding of the the present and the future scenario of the product. Okay. If we talk about the size of companies that we have really dealt with, we talk about like MNCs, like we have worked only 5% of the MNCs, and mostly the kind of form development in the product, because they don't allow you to go inside the product and change the technology, change the kind of material processes. Everything is like defined. Okay, yeah, we are going to design a medical product based on the kind of given inputs. Okay, and randomly don't suggest any kind of a change there, because the kind of a boundary already drawn there. And SMEs, like we do a sort of form development. We make soft mockups, hard mockups, working prototypes, first production piece. Yeah, we have done, but only 10% of it, because these 2 kind of the company, they at times they have in-house design team, and they have very strong engineering teams as well, but the MSMEs, they don't have either of them. Okay, they don't have designers, very less designers they have. Maybe at times they don't have it all. So they are dependent on the kind of outside agencies, or they hire someone on the freelance basis because they are small. And really, I have worked with this segment because this is like most deprived segment of the sector, first of all, need to make them understand what a design is going to do. Because if I tell them a kind of a fees, they are not going to afford it. So we need to understand his need first. Okay. And making of POCs again, because if you suggest something, quickly you have to show them something here. Form development, soft mockup, hard mockup, working prototypes, first production piece here also. But I think these MSMEs, but my experience, these MSMEs have done wonderful, because they have patented their new design, most of them. If you talk about even the large companies also, MNCs and MSMEs, they have patented my designs, and they have got awards. They've got design registration done. They've got Red Dot awards, and they are very happy. It's like first time you had a difficulty working with them, but once they understand, they don't leave you. So one has to play that kind of role. And so there's some kind of a resource available with these companies and the kind of challenges. So like if you talk about the kind of resource that is needed to design it, like you want to have a design team, the knowledge about the technology, material and processes, engineering, CAD, markup, prototyping, product testing. This is a design firm should must have. Okay. At the same time, if you talk about the MSMEs or SMEs, at times they lack capacity, because if you design something, if you really get involved with them, design something, they are not able to really take up that design. Okay. They go design something which we can do it faster, but they should be able to take it up. Okay. The kind of resources they lack resources. Knowledge of the product and the market. They have knowledge of their own product, but the market knowledge may not be fully there. And they're not able to take up the iterations, failure, rework, and refinements. Okay. So we as a design firm has to take all the responsibility in order to, because earlier we as a design firm used to give consultancy only for the kind of making a design and showing in a PPT and those kind of things. But later we realized that engineering is a must. If you don't engineer a product, they won't be able to do it. Okay. Later we further realized that if you don't make the kind of a prototype, they won't be able to do a prototype, and they're going to make some kind of a design, they are going to lose some sort of a design intent, and they will make something else. So we understood this kind of challenges are there in the market. And if you talk about the key challenges in doing a medical products here, especially in our country, first of all, they are a lower volume of production. Okay. Medical products are not in like millions of pieces. No, they're not made in millions of pieces. Only we talk about the syringes or talk about the other consumables. Yeah, they're made in millions of pieces. But if you want to talk about the ECG machine, or you talk about the CM X-rays or the defibrillator, yeah, they're made only say 100 pieces per annum, and 100 is not a quantity. So when the kind of a production volumes are low, lower investment towards tooling, because companies are not able to do the kind of investments. Because the investments are really going to be high. If you talk about CM X-ray, large parts are there. How are you going to handle them? Are you going to make the kind of a body made of sheet metal? No. Because if you make something with sheet metal, there's a kind of a limitation in the form, and that product won't sell. Product won't look good and it won't sell. Okay. So use of sheet metal and plastic combination, so we as a kind of a consultant, we started using this one, and prototype for the low volume samples, because prototype again, like you do one, and then something which is like, it's not so easy actually to get a prototype here, because we don't have a dedicated agency who can take up the prototypes. Okay. Production challenges for the lower volume part. Really, this is a really good problem, because if you make a one-off sort of a thing, nobody is going to help you out. Any kind of, even though pay them large amount, they won't pay you. Limitation to materials. If you want to explore a different kind of material and bringing up a new kind of a product, no, we have a very limited material here. Availability of good components, because components are there, like we have the switches, or you have the knobs, or you have the kind of any other component connectors, or you won't get really good quality here. Okay. The bigger companies, they kind of arrange, but the smaller SMEs, they have to live with what is available in the market. So it's kind of you can import all of many of these from abroad, and of course you can order them to a country like China or US, anywhere, and you can get a courier, but the prices are very high. Okay. Wide range of available competition from whatever you do here, you're going to compete with the competition. And now market is something which is open. People want good thing, whether you do it or they get it done from somewhere else. Because there is a competition, you need to beat that. Whatever design you're going to do must be really capable to really compete with the competition. Budget is low, project budget, usually very tight or for the design and R&D. R&D, no one want to really spend money on that. Very less company. A small company, they never wish to really spend any single kind of, they don't have budget actually for any kind of R&D, even for design as well. But we need to convince at times, let's please do design, otherwise you will lag behind. Okay, a support team from MSME side, because we as a consultants are there from outside, but the kind of a team, the MSMEs, they don't have. Okay, they have very weak team, maybe 1 or 2 CAD engineers, but they are like insufficient. So we have to, if we are really working for the MSME, we need to see that you take almost like in a full responsibility till the product gets really on the production line. So these are the key challenges when we do the medical product here in the country. And how do we find a way out? Okay. So at times we have given our hands to these MSMEs, make the design service accessible and affordable. But initially one has to do that. If you really bow down, they are not going to come to you. Okay, and once they really understand, then you can it's really convincing for them to understand the benefit out of it. Okay. And you have to go for a lot of hand holding from beginning to the end of the assignment, because they are so rigid. They get fear out. No, they please, I don't want to take this route because this is looking very unsafe. Okay, develop the designs comparable to available best competition, because whatever you do, you have to really compete the best. In terms of design, looks and feel, yeah, that should be best. Design for manufacturability. You design something which looks good, but it's not manufacturable. They may going to like it initially, but after that they are going to reject it. Design for the lower investment. We must keep in mind, if the investments are going to be larger, then nobody is going to take it. It won't be feasible for any company to manufacture it. Even the larger companies also, they always say, please, give us something, a tool which is like, a family tool, or maybe less number of tools and those kind of things. And something which a locally available material can be, it can be made with locally available material, not something to import and do it. Okay. Design with the best available components. Okay. Alignment with the vendors, okay, who could do a small volume manufacturing. Because, if you want to get a small piece turned, round piece turned, nobody like interest. Even if you pay them double or triple, because these are the real practical challenges. Okay, and if you have the quantity, they will come to you. But if you don't have a quantity, you have to go several times. You have to really plead them and then do it. But then we have a kind of alignment with them, because now we have several of the companies working with me, and we are consulted with them. So we just combine all the kind of one kind of a job and give it to them. They are happy now. Okay. It took some time, but we have those alignments. And we can say even anyone else can have similar alignments, or rework, refinements, and failure and iteration, because all these are like going to happen whenever you develop any medical product or any product that you want to do. Okay, and we will have to really accept the fact that we are a human being. We may make mistake. There will be refinement. There will be rework before you really launch a product successfully. I remember Dyson, the famous vacuum cleaner guy. He has made almost like 3,500 prototypes of his first vacuum cleaner before he succeeded in the kind of. So what do we make? Like we make 2 or 3 or 4 of them, or 5 of them, at the most 10 of them. One need to really see that we are going to be very persistent in what we do. Right? So very sample example I want to show here. This is not a medical product, but a kind of a moisture meter. And the product on the left hand side was given to me, and we just understood what is to be done. And he said, okay, the functionality, this is really good. Okay, this selling, he's even exporting to some other countries. But a moment has come to him, like he was not able to push the product for certain limit. Okay, the competition was selling almost like 70,000 rupees per piece, and he was able to sell only 6,000 or 7,000 rupees per piece. So almost like 10 times difference, more than 10 times difference. Is it because just to design? Yes. Because then we really brought this design. The left one is like all made of like sheet metal with average aesthetics. Very good function product. I must appreciate that. That's why we really got interested into helping them out. We charge them very little amount for design. Okay. So this kind of product, they lack kind of a recognition, perception, attention, because nobody will look at the product. When you have the product on the right side, which is impressive look, even this is like, 4 times, 5 times expensive, they would go for it. So we did this product and we said, if you really want to have a sort of, very geometrical shape like this, which looks impressive, you'll have to have some kind of investment. There are 2 parts to be like injection molded, 4 to 5 lakh rupees investment in that. Please arrange that and you can have this part ready. And once we have the tool, they can really go for almost like, 100,000 pieces in one go, not at all. Even you can really charge very higher. With this, the new product, whatever you're going to do must be comparable, because now the days has gone when you can really come up with a substandard product. People have really a very high kind of aspiration. They are all surrounded with the really variety of good product that you see all around. So why they're going to do something like, substandard? So everyone has a really high aspiration. Very unique example in medical product. This is a defibrillator, and my company based in Chandigarh, and they said you want a defibrillator. Earlier they used to pack in a sheet metal and do it, sell it. I said sheet metal won't do, because and they were really feeling a kind of resistance from the buyers, the hospital. They said no, we don't want things sheet metal. So the challenge was here to create something good looking, at the same time very less investment, very less. Now if you talk about this entire product in a kind of injection molded plastic, this is going to cost you not less than 30-35 lakh rupees a tooling. Okay, so we were given a target. Can we do a tooling something like less than 10 lakh rupees and still retain the design? Yes, we took that as a kind of a challenge, and we did only the front part. So we see the sheet metal and front bezel in injection molded plastic. So the rear is like sheet metal, which is just a box, but the front, which is going to have a character, some kind of a form, that is done in injection molded plastic in one piece. And that is a combination of sheet metal and plastic combination, and that really bring the product to a level. Okay, when they have the money, they'll do the back of it, but they have never done it. They said the product is looking awesome and we are happy with the outcome. We don't want to further invest in the kind of a tooling. Yet another example from Medtronic. You can see again the product here is like a sheet metal, and the front bezel like in a plastic molded car. So the top and the front is like plastic, which is a tooling cost, is a good amount of tooling cost, and the rear is all sheet metal. So this is the kind of approach wherein industry asks us to, they give a budget to us. We cannot go exceed this kind of investment, and within the kind of a parameter, kind of a specific given, we are going to design. Again, it's very similar example. If this was completely in sheet metal and looking very shabby. It's an electrocautery machine. The doctor is going to use this machine to operate and seal. Okay, and here again, I propose them the front in a plastic and the rear in a kind of sheet metal. And with the sheet metal, we give some shape to it. Okay, so we have this kind of approach, which is very common in medical sector, because the volumes are not very high. Volumes are like something in the range of say only 100 machine per annum. They cost something like 70,000, 80,000 rupees. So even though they earn a lot, but they are not in a position to invest too much in tooling. Option 1, option 2, like this. And again here something very similar option. The rear is sheet metal, the front is a CNC milled plastic. It's not molded plastic. When the volumes are again very, very low, there's 50 pieces per annum. Okay, so we need to understand that, and as per the kind of understanding, we need to really take a direction to tweak it and make it. A very classic example here again with a Mumbai-based client, Blood Centrifuge, wherein we have again metal and FRP products. FRP, fiber reinforced plastic, because here you can't go for injection molding. So it's a very good study here. When you can see that how the design thinking and the design approach changes here. It's like this is the product on the right hand side. This product is all made of sheet metal. It's a blood centrifuge. You're going to have a blood bag in a pocket there, and you're going to rotate it almost like a 6,000 RPM. With that rotation, what happens? Plasma and the blood and the plasma gets separated out slightly. Slowly, you can take out the plasma and the blood cells. So this is a very crude looking product. They have been manufacturing this product for, I think, last 40 years. When I approached them in 2005, they said they want to enhance the design just because product was doing good, but they want to enhance the design because, they are a stiff competition from Haras or other kind of imported machineries, imported kind of blood centrifuges, and they have to go for it. Okay? They wanted to revamp the design. If you see the kind of internals, very crude, all mild steel kind of powder coated, welded structure, and very complex shape. This is a refrigerated as well, so many wires here and there. And I said, yes, I'm more than interior. You need first of all the exterior looks. Okay, because this looks like in a really boxy. This 1 meter by 1 meter by almost like 1 meter, and this looks really humongous in size, very heavy, and very, also dangerous because rotating at 6,000 RPM, you have the rotor inside which are heavy. So you need to really handle those kind of a detail along with the kind of a detail that you see the power switch on the side, very crudely done. And why they don't understand even these things really does matter. If you see the modern product, all the latest product we have, we don't see a single screw anywhere. Because when we design any kind of product, we are going to hide the screws. We are going to minimize the kind of a welding, because whenever you're going to weld a kind of a screw sections together, you're going to finish it. Very, very messy job. Can we have a design which really eliminate these kind of process? So as a kind of broader thinking, we just take this in the account, less of welding, and the screws which are there, which are something from hidden points, not directly visible to the eyes. Right? So we identified all the several points wherever we saw that. And these corners I'm especially marking here because I really wanted to give a larger radii in the corner to soften the product. But they said, so we change it, let's change the design, but please see that this structure doesn't get changed. Because structure is like something which is optimized. Which if you tweak the structure, then your strength of the kind of a thing is going to get really compromised. So don't compromise on the strength of the kind of this structure. I should find. So we identify these kind of corners because unless you give a kind of a generous radius to the corners, and a kind of, which we call it a radii manipulation, you won't be able to come with a form which have a kind of a softer look from the outside. To get a softer look, you need to understand the internal first. Whether do we have a freedom or not? Okay, we identified that. You see this kind of a rotor inside. You have a drum and a very high-speed rotating rotors, very dangerous looking. But overall construction was really a very kind of a crude machine, and the blood bag doesn't go really well. To make them convinced that I can do this in plastic, some portion in plastic, it took really quite a time. And this is the design which I proposed to them. And, the chairman said, no, I really don't like it because, this is not manufacturable. I said, I'm going to manufacture and give it to you, please. Because what I did here, I've used a very generous radius in the front, both the sides, all the sheet metal only. This sheet metal, but this is plastic and this top plate is plastic. Unless you have a plastic, you can't give a shape to that. So it took quite a time to make them understand that plastic in a vacuum form can really do a really good job. At the same time, it's going to be manufacturable and within the cost. So when all the parameters are met, then they allowed me to approve the design, and we gone for a sort of prototype. And you can see this, that very crude looking machine has become a softer one. This is the very first version which came out of the production after 3 months of design and engineering exercise. You see the internals, they're really nicely done. But the lid here goes in the reverse way on here, somewhere here. We have some surface kind of undulation here. They're very soft looking corners. We have the machine which looks smaller than the previous one. The machine in a lighter color make it yet look like lighter. We can see the kind of a dome which make it yet look really very organic shape. So this was really liked them. And of course, they're very initial pieces, but I think later on we gone for a color combination and a lot of product graphics that make it really yet much more impressive one. So this is, you can see it on the production line, the old version versus the new version machine. So this is what we took approach, wherein really a good amount of effort has gone from a very crude machine to a really soft looking machine. The first generation. After that, they given me the entire range of almost like a 70 product to be done design for them. So this was kind of a one, when you break the ice, when they break the ice, then we're given an opportunity to touch all the other products. Okay? So likewise, we started doing the rest of the product with the same category. Okay. And you see the internals, like, we have not ignored the kind of we are not only focused on the external, but at the same time, how I'm going to really achieve the mechanical strength, the kind of a internal mechanical. You can see this red part, which is like a stainless steel, steel. And then we have the top and the bottom, which are in plastic component. They are all sandwiched together and yet within the cost. We are not exceeding the cost. Okay. But so this plastic has given me the looks, and the red one, that part here, has given me the strength. Very new part like gas hinges, like other kind of a gaskets, those things we propose, the additional kind of a box to them. This was really one good example, which has metal, which I propose. Another sheet metal product is, sort of a incubator shaker for the same company. You can see this again. I started giving that very generous radii to this corner, because this radii are going to help you out in really overall looking the product softer. Again, this is like full in metal. So it's so difficult to get a kind of a soft look in a metal, because if you don't have, if you're going to bend it at right angle with a sharp edge, metal is going to make the product very harsh. Okay, so this kind of a the treatment to the sheet metal, the bending radii, and at the same time choosing a right kind of a color combination for the product, make the product look little impressive. Because here also they don't have the volume; they had only volume of 200 units per annum, which is hardly in volume, and nobody would go for such large investment for the front molded part. If you go for a front molded part in plastic injection mold, that may cost something like 30-35 lakhs again. And you don't have a kind of a return. So, and people naturally they select, and the proposal was declined. Okay, now we don't only just suggest the kind of injection molding everywhere, because we have other methods in medical, like you have the kind of knobs, the small components, because even these smaller components add to a value to the product. And you're not going to always choose an injection molding in the process, but this is called a vacuum. It's a vertical molding. Vertical molding, the molds are simpler, machines are simpler, and you yet can get a part which is like as professional as this. Okay, so we have a vertical molding process. The mold for this two part, one is the end cap, one is the kind of knob, just 40,000 rupees. If I have to go to choose an injection molding process, this may cost me about not less than 2.5 lakh rupees. We have got the job done in just by 15% of the cost. Because I don't have a volume. I have a volume of say 500 such knobs and end caps. That's all. So if I have that low volume, we have to go for something which is cost effective. These smaller parts, like you have very small injection molded parts, all from vacuum vertical mold process. Very impressive looking part. You can see this, the trial mold, the left one, the finished mold on the right hand side, the vertical mold process. And you can really you can't make it out this is an injection mold or a vertical mold. Okay, only thing you'll have to choose a right vendor who understands the design, who doesn't really sacrifice your design anywhere. And so this is what a vertical and a horizontal mold. This is a horizontal mold which is expensive, but this is a vertical mold. Even the machine is smaller, and you have a limitation on the machine because you can't make a very big part in vertical mold. You have a grammage kind of a limitation of 50 grams to 100 gram part can be made using vertical mold. So while designing, you must keep in mind, in case if you have a lower volume, please go for something which is like a vertical mold, go for something which is like only the front bezel in plastics and the metal combination, and likewise. That way you can really convince your client to have a kind of investment which is lesser. This is such impressive sample in vertical mold. Very good looking parts, right? So these we apply to most of the kind of medical equipment sector, because medical equipment is something again really very challenging one to work with. Okay? Of course, company like Johnson & Johnson, Medtronics, and BPL can afford to have a larger molds, but the smaller kind of SMEs and MSMEs, they can't really shell out for all the parts. Another good study that I really want to share here is like product design and development of a baby warmer. And this is a Delhi-based client, and they gave us two sample benchmarks. But they like the aesthetic. They went to China and they really found these two products very impressive. And they said, okay, why don't you just copy them? I said, no, we can't copy. But we are designers, we can't copy. We can really, of course, we can retain the design intent. We can come up with something good. No, something good is fine, but we don't want to invest it. Can you really make something which is like really manufacturable, good looking, and something which is very easy to produce, compact in kind of a packed condition, those kind of attribute they wanted us. And what we did is like, they gave a kind of brief wherein key objective is to match the same aesthetics, low cost, baby one. Okay, the kind of the machine what you saw here, this one, each one of them are costing 2 lakh rupees. And we were given a target to within 30 and 40,000 rupees. Can you develop the same machine? 40,000 rupees. Okay. So to achieve this kind of target, when you have to really do a kind of when you have to match the aesthetics, and you're not going to make the same aesthetics. This particular product is having so many larger kind of injection molded parts. This larger parts, very larger part on top. If you see this top and bottom, 2 large molds. Again, this is a very large mold here also. You have the large mold on this portion also. They made this common, but we can't afford this kind of investment. If we talk about the investment towards making of all the tools, roughly around maybe 1.5 crores. Who has the money, this kind of money? Can we really, understand the intent here, understand the need here, and we will say yes, we will try to have a comparable aesthetics and lower unit cost, because you make something, you design something good, and at the same time manufacturing by the cost should be low, and cost target is 40,000 rupees. Use of some injection molded plastic parts, bigger and smaller combination of them. Simple to produce parts, like an essential feature, because if you make a part which is very complex, the part cost is go high. You need a skilled manpower. So if you have a part which is like really simple to produce, any unskilled, semi-skilled person can handle that. A product with lesser welding, as it's consumed more time to finish. I've just written a note here: less welding or no welding. The product design is built as standard components. If you're going to use also all like in a special component, you're going to increase the cost. So can we really build a part with the standard components which are readily available? Product that can be knocked down for a smaller package, because the smaller the footprint, the better with the logistic. If you want to ship it to Coimbatore from Delhi, they're going to be cost. Okay, so all these we kept in mind, and we just say we can try to achieve a high aesthetic, low cost baby mom. So from say 2 lakh rupees to 40,000 rupees, and what are the kind of ways and means? Add plastic injection molded part, large and small. Add part which made from vertical molds. Use of sheet metal with larger bending radii. You can see that these are like real practical means to achieve that. Material of construction, like what things which are available locally. If you go for a specialty one, no, you are not going to meet the cost then. Sheet metal, injection molded plastic, acrylic, FRP. Okay, attention to detail like soft color scheme, product instruction graphics. Because they will make a product, but they will not make a good product instruction graphics. Or they won't choose a kind of a softer color. They will have a very weird color schemes. Okay, and a healthy team. Because if you really work for them, see if the teamwork is not there. Because there is kind of a 3 or 4 people from the client side, and from my side 3 or 4 people. They are going to work in sync. At times it happens, people come in a kind of like pulling mode. If they don't have right end, the product cannot be made. Okay, give me a second. So these are the kind of how we're going to achieve. The very first thing I said, prepare a costing sheet. Because if we don't have a kind of control on use of component or material and process, we are not going to achieve the target. The very first thing is like prepare a costing sheet, design with the constraints. If you really want something, what is the material, what is the process? One must know really. Design for manufacturability. That's a larger volume and lesser cost. Okay, so these are the kind of 12 different kind of point that we prepared, and we said if we really follow all these 12, we are going to achieve the kind of success. Okay, so what should we aim for? At this cost also, we always aim for something really winning a red dot. If you get the same aesthetic in a so low price, you're bound to get a red dot if you apply for that or any award. Okay, because this is something which is like something seems unachievable. The kind of the benefit of our country is like, and we have a really affordable labor, we have the talent, okay, we have the resources, okay, that but within the kind of a given resources we can do wonders. Okay, design is such a good product that it doesn't take any effort to push into market. Okay, so these kind of the kind of we always aim to win at a dot. And if you see this kind of the current existing product they have this very average looking product. They're selling for last so many years. They're doing good. They're competing with even the international one, but the kind of looks and feel they have, like really not acceptable. Okay, very crude details. But I'm really inclined towards really designing the product, and we have done a very good thing. And we see this product which are like really doesn't go well with the baby. And we propose a design which is like a sheet metal product. This is all sheet metal product, except one part which is shown here is like transparent. This is acrylic, which is like thermo formed. Otherwise, every part is like sheet metal product. These corners they have the corners in an injection molded product. They may already had a tool. So this is one plastic part. This is one plastic part and one small FRP part there. Otherwise, all the parts in metal and all manufacturable within a given cost. You can see you can really keep this kind of a design side by side to any competition. And I really bet that this is really going to win. And within the kind of got this amazing work. They really like the design. They are they have gone for the first trial and production. Okay, they have got a very good response from Arab Health. Okay, so this is that's what I'm saying. If you see the kind of this small manufacturer, they have a kind of a high aspiration, and if you really join our energies together, we are going to do our wonders. I'll cover this quickly. This I've shown many times. Vertical difference cell apparatus. A scientist came up with this kind of a unique idea to have a product, and we did it, and we did really good. Because this was really, we understood, again, the kind of approach or design thinking gone in bringing up this product is completely different. Okay, we need to make something which is extremely low in volume. And we started with the kind of making the POCs, because these POCs are necessary. We combined the internal kind of mechanism wherein you have the kind of magnetic stirrer, heater, and rotor all together. And when we done the internal, then we started building up the product, and quickly we just made an assembly and made a kind of working prototype. Because these people think that if you really show them in a kind of 3D renders, it's very easy. Can really show in the manufacturing process, and this is what we follow. We really do it, and this is during the translation from the 3D CAD to the final making of this prototype. Yeah, it's a good effort. 3 engineers, 2 working prototype makers, and it took a month to make this. Okay, but the initial first piece take time because we need to iterate several times to achieve at the final one. And when we achieve one, then it's going there. They have started making. Any average person can make that. Okay. So Ambala, I'll see that. So that Ambala is again a very good example here. When you have this very average-looking, old-fashioned product, there was somewhere in 80s and 90s, very boxy and very kind of sharp looks, which it used to be a kind of a language in the kind of microscope, but a time has come when they were bound to change, and we have shown the kind of the kind of a change that can happen, that can bring to a product. So the old one is on the left hand side, right one is the new design, proposed design, and all the black part what you see is like in a given component. So within a given component, you have a challenge to design a new form, and without changing the optical layout. Without changing any kind of a mechanism, because one such microscope is going to have 400 precision parts. If you change one single place, you're going to change the internal layout of it. So please keep that in mind. We have to keep that in mind. We have come up with the form. We made a kind of a process to convince that new form is going to house all the kind of internal components. And without altering the functionality and the optical path, we are going to have a microscope which is going to look really so different. You can see between the initial and the final one. This is another microscope, but you can see the way we design. Now, this microscope, like really design has added a lot of value addition here. Use of plastic part has improved the aesthetic in a substantial way. It's a lighter product because the entire body is made of kind of a, you have the die-cast steel, pressure die casting aluminum and a plastic components. Lower the cost of manufacturing. Because if you really lower the cost, the customer are going to be really very happy. Increase in production because you have the plastic parts. Plastic had got inherent properties wherein you have all the details of, and assembly in the plastic is so simple. So this is what we have achieved. You can see the quality of these microscopes, which are doing really so good in international market. Now, all of them are like in 100% export. Only they used to make a very boxy, very simple looking one, average looking one. And after that, they have started winning the red dot awards. One point of time, they realized we need to really go to red dots, and they have won for the hat-trick radar, 13, 14, and 15. I'm really proud of them. Okay, you see the quality. I mean, there's like really comparable, the best in the kind of industry you have actually. Okay, and all done in India, all done in a small place called Ambala. There's a process when we design, we just convert that into a puff model, a form. From there, they take it forward. So there are some examples. I'll run this quick. We are just running out of time, and for them, it's like a really good example when so much of kind of when one company has so much done well with kind of interventions. So like these are the competition with the immediate competition to Lemonade. One is Leica, world known, Nikon, Olympus, Jazz. Okay, and the fifth name came in an international like Lemonade. It's like from India. So they are Indian #1 and world #5 position. They have very good setup in Ambala. All kind of a CNC machine they have, and they have really progressed multiple folds since I think 2005. I have been working with them. So I'm the only designer who really worked with them, and classic examples. And this was even documented by IT Guwahati one point of time, and for the kind of unique work that contributed. And some of the other things which I run quickly, but they're very impressive one. This is one particular microscope, Sigma one. Student microscope, wherein you're not supposed to take out any IPs or those things. And the final outcome I can show you here. This is the final outcome of this machine, this kind of a product. This is a $60 microscope, and this is the first time which are done the entire body in plastics, left and right. And inside we have the kind of a structure which we can see it here. Here, the black part on the right hand side is a structure that is taking the all kind of optical, all the mechanical load and keeping the optical path in place, and the plastic part is going to give the aesthetic. And this was so nicely covered. I mean, this will become the cover page for 2 American magazines. $60, nothing, but a very high magnification, 1000x, and very low cost at the same time. Wonderful kind of image. Okay. So defense, again, I have a lot of contribution to defense, very important ones. And if you talk about like, man-mounted air conditioner, I mean, talk about this product, extreme kind of a heat to extreme kind of a cold. And we developed a product called air conditioner system. Here, the kind of a design thinking is altogether different. Because, you're going to, first of all, prove the kind of technology. We are going to develop a technology for the cooling and the heating. And once you have done that, then you can really move on to the next phase of design. It took almost 2 years, but we really did them successfully. And the kind of first aid kit, we have the NBC first aid kit. And this was like earlier product. I can't show the real one because I'm not supposed to. But this is the earlier product they used to manufacture, and this is not designed by the English people just before freedom only. And after that, this was something, very heavy, epoxy, not looking good. And we designed something in the plastic, which were unbreakable, floating, and having a very nice look, having a look of army and those things. Other first aid kit, this is the RVD kit. Yeah. So these are like products which are very unique. These are again patented. The first aid kit is patented. This is patented. Okay. So the nature of our design assignment here is like with the defenses like design, engineering, prototyping, and manufacturing. They just don't want to design. Because if your product doesn't function, you're not going to get payment. Okay. So achieve function followed up with the form, because you achieve the function first. If the product is functional, then you do the form. Otherwise, form is like secondary. Okay. End product must pass through several test parameters. If it's not going to pass, then the product is going to fail. And we are supposed to write a design patent, utility patent, also the production and supply. And for the first aid kit A cycle that we have done it, we have almost supplied to full trucks of first aid kit to them, because we were supposed to manufacture and sell to them, and then we have done it successfully. For other healthcare sector, we have several other products done, and everywhere we felt the same kind of constraint of less budget in, because all these bigger part like a blood chemistry analyzer, the investment was in the tune of 55 lakh rupees. Yes, client took a pain and they manufactured one tool, and this was done in 2009. And since then, last 13 years, they have been selling this product successfully. Not only selling, they're exporting this product to so many countries. Okay. We made a prototype. We made a tool and we tested everything, and then we really, this was doing well. To a simple product like ACG machine, it's all plastic. You can't think of a metal. The investment will be in the tune of 35 to 40 lakh again. But then, because this is the highest selling product, in a year you're going to sell almost 20,000. Even 20,000 is not a quantity for an injection molding part. But they have taken to, because you have to go for injection molding parts. So all these parts are like, because plastic is going to add you need to convince them some way to use the plastics. Okay. Okay. So like some example here, I think we have just, we have to scroll the time. Something again, one last point here I want to show that the CM X-ray, interesting one, because here what you do when you approach a CM X-ray, what you do is like you design inside out. You first do the internals, and internal was I knew that the product was not going to do well because internal was so badly designed. The mechanism was not good. In a kind of operation theater and chain and rack and pinion, no, that's not done. Can we have something like actuator? And this is the kind of a thing we really developed. So this was a kind of a POC. And the POC, when it worked for 3 months, 3 months continuous, then they selected the design to take it to the kind of next phase of form development. This you can see how the form has come up and how this product has come up. So internal and then the external design. This was really taken, and this is really doing very good in the market. The first piece which has come out well, because they wanted to have a good shape, good piece of technology, good amount of mechanical engineering, and the product is very soft looking. The family of the other products, and this is like Chorus 9 is doing extremely well in the market. Okay, I'll skip all these other parts because we go inside of that. Finally, the ground relatives here is like an SMEs and MSMEs do realize the importance of design to stand in the market. Okay, and we need to understand that we as a design need to help them out, because not every time they would be able to afford you, but at times you need to really give a helping hand, and after that, when they get the kind of input, they're going to really pay you well. Okay, they do have budget and resources constraint. Yes, all of them. Okay, they wish to have things ready. I mean, ideally they don't want to give time for the R&D and design. If they have money, they want it the other day, next day. Okay, in-house team is usually takes in-house team is like redundant, always redundant. They just engage in very incremental changes here and there, because they're manufacturing a product, they are engaged in somewhere else, and not a capital kind of a design. So only the external agencies can really help them out in a better way. Okay, external design agency can help to support this kind of company, and one need to work out a win-win situation to have a long-term relationship. Initially, you'll have to go down, but after that, you'll feel that. So I have at least almost 5 companies with whom they have become like a part of me. I become a part of them. It's like that. So unless you do that, nobody's going to win. Okay, and that's how you have a command on them. Of course, they started paying as well after some point of time. Okay, so once the MSC understand the benefit and start getting returns, they have all respect for you, right? So we design a must serve all the SMEs, MSMEs, and I guess, and design would add to recognition of a better business. This is really good term we need to understand. Thank you so much. And if you have any questions, we can really take it up.
Thank you, Sudhir Kumar sir, for your valuable insights. We have some questions from the audience.
Yeah.
Yes, so we have a couple of questions from the audience.
Okay.
Question, can you expand more on being revolutionary and not incremental when design when the client already has a strong design direction and design language?
Yeah, of course. What happens, like, they at times they are inclined to one particular design because they have seen something somewhere and they say, okay, I mean, this is the best what they know. Okay, best in what terms? In terms of only looks, or in terms of functionality, or in terms of like cost of manufacturing? There's so many aspects of it actually. So when you really, do a product analysis, we'll come to know that product is good in what cost, what sort of a manufacturing kind of a practices. And if you really know the weaknesses of the product that they are suggesting, you can really win over that. You come up with something which is like yet different, yet much more better, and we have done several times.
Sir, there is one more question. What are the other limitations in exploring newer materials for design of medical devices besides the budget?
See, first of all, availability of these new materials is very, very less because we have a limited materials here. If you talk about injection molding, you talk about other kind of a processes, we have limitations. Okay, so in case we get something new, yes, we try to procure them, try to utilize here, try to use them here. Give an experiment, but it's challenge always remain a challenge.
Thank you, sir. I hope the audience are satisfied with the answers, and I'm sure the participants were intrigued with the applications of design thinking. The session has now come to an end. We will shortly begin with the next session at 3:30 p.m. on the same link. We look forward to meeting you all there. Thank you. Thank you, sir.
Okay. Thank you, all of you. Bye.
within my head is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Whoa, mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Whoa, mama, oh yeah. acting like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Oh mama, oh yeah. like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. Cause in the wild I was getting drunk with something I don't know. Whoa, mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Whoa, mama, oh yeah. Whoa, mama, oh yeah.
Welcome to session 3 of DeW 8.0. on emerging autonomous healthcare systems by Mr. Sudhir Kumar. Now, I would like to invite Professor Tanuja Shirove from the Mechanical Engineering Department to take over. Over to you, ma'am.
Good afternoon, everybody. This is Professor Tanuja Shirove from Mechanical Engineering. And first of all, I would like to thank DeW team for giving me this opportunity to chair the session. Though the session 2 is Mr. Sudhir Kumar was introduced, but I would like to point out few things and for the benefit of those who have joined late. Basically, Mr. Sudhir Kumar is a mechanical engineer and he has studied the degree of NID as well. So that's the best combination for futuristic design of the product. He is the recipient of Hindi Hitachi scholarship and he has given information to our own students. Thank you for that, Mr. Sudhir Kumar. Then he is having around 70 products with reference to diagnostic and therapeutic medical devices, which he did design and development, plus 300 plus professional projects in his credit. In the earlier session, he aptly talked about the design should not only be functional, but it should be deployable. It should have aesthetics, ergonomics, and he has given quite a detailed view on design thinking. Now, as the AI is coming of age, the AI engineers and designers can possibly contribute a lot towards healthcare development, device development also. So he will be talking more on emerging autonomous healthcare system. I would like to invite Mr. Sudhir Kumar to deliver the talk. Mr. Sudhir Kumar.
Yeah, thank you, Dr. Tanuja. Yeah, I'm really thankful to IIIT and all the students of IIIT who have really organized a so nice kind of a workshop here, and they're very active participation. Thank you all the team of MDIS and BDIS who has really contributed toward this wonderful workshop. And let me share my screen here, and I have a topic given on emerging autonomous healthcare system. 1 second. Is my screen visible?
Yes.
Okay. Let's make it full screen. So, as I told in the very previous session, healthcare is something which is very close to me, and I really worked, and I'm still working on several of the projects in the healthcare sector. And this is something which need a kind of support from our design team. And we don't only kind of design, we just manufacture, and we are entering into that sort of manufacturing as well. Because unless you do that, the journey is not complete. Because the client and the SMEs and MSMEs, they really they need that kind of hand-holding, and we must get them. Right? So this is slightly, again in the healthcare topic only, but the autonomous mode and emerging autonomous healthcare system. So, and this is really, this picture itself shows that you are going to be, making the machine, like empowering a machine to think like you, and something helping you, and which is going to take up some other kind of job, because not all the kind of a job, you can really trust the machine. We can assign those functions to machine, and yeah, that's going to get. So we have today in the advanced scenario, we have we are living in the age of technology, and we have driverless trains, we have fly-by-wire autopilot aircrafts, self-driving autonomous cars, autonomous robots, and many of them. If you talk about industry like car industry, you must have heard that we have several of the robots doing the job. They do very accurately and very precisely without any kind of mistakes. And we have been hearing about the self-driving autonomous car, driverless cars. Okay, these are going to be the world of tomorrow. Okay, and we also need to see that where are we what is that we are doing, and what are the capabilities we have. So if you talk about the AI, the global market value is going to be in a tune of say 34 billion by 2025. And the best part is here, we have a good resources. We have good resources of engineers and designers and very talented engineers and designers. I must appreciate that because I've been taking course as a faculty, visiting faculty in IIIT. And I've seen people working on different kind of domains, and they come up with wonderful kind of creations. Only thing we need to realize how we're going to really tap them, convert into something meaningful, and that is going to help you out, mankind. Okay. So coming to the driverless trains, if we talk about this, we really don't have the drivers, and the purpose of is this is Japan Railways East, and which hope to automate system will reduce the human errors. The first and foremost thing is human errors. Many times we have heard that the driver has gone for sleep. He got a kind of maybe some kind of error because of his health conditions, okay? And improve the safety, okay? Because a human being may make mistakes, but if you really automate something which is going to take care of most of the important aspect, yeah. And even the kind of labor shortage we have, if you have a repetitive job, and we really want that to assign to a machine, yes, that really can does a specific job. We need to understand. In case of any error while driving this kind of a train or a car, we may have fallen accidents, a car, train, or whatever. And these are like mechanical errors. They are some sort of error by a human being. You applied the brake, but something else happened. Or you applied the brake, but the brake didn't work. Those kind of. So you end up in a situation, accident. At the same time, you have kind of a shortage of skilled labor, because with time, what happens, people are there, but they're losing it. They're not having the same skills. The skill who really made the Taj Mahal, it may not exist today. Okay, the kind of so those intricate kind of carvings in caves which are there in different part of our country, you may not get those kind of skills here. The kind of furniture used to make very good carvings and all, handmade carvings. We are dependent more on the machine than kind of man. So we have a shortage of skill and semi-labors. And autonomous car, yes, we are going to decrease the cost, and increase the safety, because you're actually buying time and you're buying the kind of a safety. So a car which can really take you from point A to point B without making any sort of without jumping the kind of a traffic rules or jumping the red lights, and safely you want to transport from the point 1 to point A to point B, and without any kind of hassles. Okay, so we already have autonomous robots in several fields that are actually working. There are so many fiction movies made on these autonomous robots doing a different kind of a job. So with the kind of improved speed and accuracy of routine operations, because things we are going to do routinely, that is sort of a production job. Okay? So particularly in warehousing and manufacturing, these robots are really so efficient. You're just going to take care of the robots, and robot is going to take care of your routine operations, right? Add efficiency through side-by-side work with humans. Okay, because if the things which are not fully automated, yeah, humans are going to take some portion of it, and then a portion is taken by the robot, and then you do a very much efficient job. Reduce the risk of employee injury in dangerous environment. Means you're really under a mine, or in a situation where the radioactive things are there, or some handling explosive, or something which is like in a really very threat. I mean, robot can do the job. So these all we are hearing, and we have been hearing about the kind of these capability of these robots. And in healthcare specifically, you can have these kind of system which you can a kind of a thing which on the reference side you want to transport from one portion of the hospital to another portion. Yeah, we automate this. Is automated. It can go off its own. It knows where it has to go. It has to be deliver the item there. Okay, or we have the robotic surgery. Okay, so 1 second. Yeah. So the robotics and autonomous system have become a part of everyday life, and exponential growth is anticipated in area including machine, including medicine, transportation, supply chain, and space exploration. Right? So we are going to be living in this world, and the scientists and the engineers and designers are really working on these kind of autonomous system which can of its own help you out. So autonomous robot in healthcare can be segmented in assistive. They're going to assist you. Okay, they're going to rehabilitation mode, humanoid, delivery, implant, surveillance, and security. So many aspects of it in healthcare. Apart from other industry, they are already there and they are doing a good job. So in assistive, you can see that, if you want to make a smaller incision in a kind of a surgery, using this Da Vinci surgical system, which is partly controlled by, the manual operation by doctor, partly by the machine. And if you really define a path of a surgery or depth of cut, yeah, that machine can do a very great amount of precision. Okay. So this is how a kind of a machine, man and machine working together and give you a kind of assist you. This assists you making a very fine surgery, very critical surgery effectively. Rehabilitation. This is really important. I mean, you can see this, how this machine is really a human and machine are really working. The machine is actually helping the human to perform certain kind of a task, certain kind of designated movements, and slowly you gain a kind of a moment, gain a kind of a strength in the body part. If you have an upper limb or lower limb exercise, if you are really taking some portion slowly, you start slowly loading the kind of human being. If you have a fracture in the leg, and if you're going a kind of this gait analysis test or procedure, you slowly machine will allow you to take the portion of the load to your legs, and that's how you, within certain time, you gain a kind of a strength in your leg and other body parts. So this is like machines are intelligent enough. They can assist you. They can really make you something capable. Humanoids, yeah, they can do a job like this. This looks like, something very futuristic, but I think the people are already taking help of this robo bear. And this really looks good. They don't look like a machine. They look like as if they are like soldiers and they are like hospital guys. Okay, so they can really do this kind of very simple task easily. And these are not very difficult. Only thing we need to understand, even we can really think of making it. One need to be passionate. One need to identify the need. One need to work on it, and then really we can get. We have autonomous delivery robots anywhere within the hospital or in the periphery of some kind of a distance. You can do that. On the right hand side, you can see this kind of injection of medicine which can be given to, within the other departments. So these are again going to assist you, because otherwise you will have to have a manpower, a full-time salaried person, and you need to maintain that, and you need to employ them and all such things. So autonomous implant surgery, which is a very new recent one, like a robot in China carried out first autonomous dental implant surgery, okay, and fitted with two 3D printed teeth into a woman's mouth. In the R operation, the robot was able to fit the implant within the required standard of margin of error and make adjustment, because robots are doing certain jobs, okay, and they are even guided by kind of human interventions, and they are going to some sort of intervention, but by and large, they are given a parameter where to fit it, what depth to be drilled, what kind of to be removed, and all those commands. Okay, so they are going to work autonomously and do this kind of a surgery. Autonomous surveillance and security. Yes, these kind of robots are robot-looking kind of things are there, which have night scope and which have been taken into two of them taken into security, and they are doing their own job. So they are like designated. They are like work without any kind of a biases. Okay, they are going to really surveillance or maybe have a security. No need to have only the human intervention. Human can be biased, but these robots are not. Okay, so if you this is all about the kind of autonomous system, but if I really look into my professional work, even I am doing a sort of innovation, autonomous system in healthcare system, which I'd really like to discuss here. So I have been associated with defense in the DRDO lab for quite some time. It's 2006 onwards, and last I think 17 or 18 years, and I have given so many products to defense, like not only the cosmetic design, but the design which really take care of the human being, take kind of very critical kind of an action. So this is one kind of a product, auto injectors. And the injection is so critical, like these are life-saving injections. And they, in case of any chemical warfare, if you don't take these injections in a sequence, means the red one first and the green one second, within the time span of 30 seconds, you're dead. So in the event of a chemical war, I mean, all the soldiers on the paramilitary force or the commandos, they're going to have this injection on the on their right pocket. And in event, they just come to know there is a kind of a chemical weapon which is fired, and you are not going to think twice. You're going to take out the injection. Whenever you open this particular case which we have designed, you're going to access to only the first one first. Okay, and only when you have taken, these are auto fire injection, means you take it out and you have to just unlock it and place it, push a trigger here, a small trigger here, and aim it to the body part on top of the kind of your suits. You're going to get an injection. Okay, you're not supposed to take out your clothes. Not supposed. You're going to take it by yourself. Okay, it's some sort of autonomous. I won't say this fully, but this is like going to assist you in taking the injection within no time and within that kind of a very tight span of 30 seconds. Okay, because this comes to life. So these are like other injections which are from the foreign countries, but we have developed this indigenously in India. The scientists from the DID Gwalior, and we work together to develop this one. And apart from that, we are working on a physiotherapy device, wherein on the left-hand side you see a machine which gives an exercise on the upper kind of limb, not the lower limb, only the upper limb exercise. In case you want to have a kind of a exercise on the upper limb, left hand or right hand, and you want to have certain kind of a motion to be performed because you had some kind of a surgery, or you are a kind of a stroke patient, or you have some other kind of a defect, and you're supposed to do a physiotherapy, then this is the device which understand your need first, what action is to be like your hand to be moved, and base that machine understand and really take you for that kind of a cycle of kind of repetition of that exercise. And you're going to take this kind of a therapy for say next 2 weeks or 4 weeks, right? The right one is again a sort of a physiotherapy device, which is done by a company called DeW, and I think from Germany. And these are again the very similar kind of exercises for physiotherapy, and you're going to have the upper limb and the lower limb exercises. But both the machines are very expensive. Both the devices costing not less than 1 crore. Okay, because in our country, like if you really talk about the only, of course, I mean, a bigger kind of hospital, they can afford to have these kind of expensive machines. But then we, as a design company, we are involved in making of us a kind of a device, again, a assistive physiotherapy device, which can work on a passive and an active mode, and it can perform almost like 18 different exercises for upper limb and lower limb, and that to cost of only 5 lakh rupees. And we have already done this. I can't show you the picture here because the product is not launched. So, but I want to just say that, like the engineers and designers here in the country, they can really contribute. If they spend time, you can do anything you want. Okay, anything really good. And we have come with a much smaller machine, much portable machine, and much more effective. Very simple in design, very simple in construction, very low cost. Okay, and that is all gaming based. Okay, you're going to have a screen in front of you. You're going to have all the kind of a sensor, parameter, app driven, those kind of things. So there's a team in Hyderabad who does the kind of app application design and the kind of a control of motion. You just give a command to the machine, what degree you want to move your hand, and that's going to repeat the number of actions, and you're going to perform the exercise. So this is again the second exercise. And third one is something for the Indian Army, where we developed a product called a man-mounted air condition for the extreme climate condition. If you are in a situation, the machine, the kind of device is going to operate by itself and keep your body west part cool or heat as per the kind of scenario you're going to be then. If you are in extreme climate, extreme cold condition, is going to heat your body. The extreme hot condition is going to cool your body. And this is what we developed, I think, way back in 2015. And successfully we have done it. So man-mounted air conditioning system works automatically, and it's really keep the west part really cool, because these soldiers are in a kind of extreme climate condition. If they are temperature above say 50 degree, where in the Rajasthan Jaisalmer it really goes, it's going to cool down your body to say about between 37 and 40 degrees centigrade, and you are in your body physiologies remain there. We have also done a kind of a health kiosk when a patient can approach, and not this one. This is a kind of indicative design, but we have done a much better one and a much compact one, and something which really a person feel like going there and testing by itself. So these kind of a device which can test all the vital parameters by itself. Okay, So you're supposed to be spending some amount of time there. Machine is going to guide you, and you get the kind of a test done. You can speak to the doctor in the screen. You can sit there. You can do your kind of a BP or this kind of temperature. And apart from that, also you can urine test and blood test. So many other things can be done here. If you want to do a spirometry or you want to have some kind of ear test, yeah, you can be done. Okay, so these are kind of our experience in basically designing the systems. Now we have to look at the kind of Indian scenario and the autonomous. Okay, so if you talk about the Indian scenario, what we have facts here is like we have only 7.77 doctors per 10,000 persons, and WHO said it has to be minimum 23 doctors per 10,000 persons. So we are very less. What is that we are going to do? Okay, and if you talk about these, out of these doctors, what we have in a country, 80% of them doctors are there in like cities. And for the rural, only 28% of the doctors are there in the rural. So the kind of, you have the larger masses residing in kind of rural. So we need a kind of a system and things. And out of these kind of Punjab, Kerala, Karnataka, Tamil Nadu, Punjab, and Goa are having more number of doctors as per the WHO standard. But apart from the, if you see like Rajasthan, Gujarat, Madhya Pradesh, Maharashtra, Chhattisgarh, Odisha, and other Arunachal Pradesh, they are having less number of doctors. This is not only the doctor, you need a kind of, along with the doctor, you need other kind of medical staffs to make the kind of system complete. And then you really need something which can work on its own. So the challenges here, like as per the kind of Dr. Naresh Trihan, who is the CMD of Vedanta, despite the government effort, majority of our people remain deprived of access to healthcare, especially at the secondary and the tertiary level. Yes, this is a fact. Okay, and we need to understand that. Across the healthcare spectrum, lack of infrastructure access, skilled professional is pointing out that skilled professionals, quality, patient awareness, and use of healthcare insurance are. So if there is a kind of healthcare spectrum, lack of infrastructure, then so you are going to build up a hospital, all the cities? Not possible actually. So can you have some alternatives? Okay, when a doctor visits the kind of a patient, not a patient visit doctor, or something like that, or some sort of an automation which is going to solve the problem. We as the designers are going to understand where the kind of gaps are and how with the use of technology, we are going to solve that. Okay. So doctor can't, doctor has his own job to do. Engineers have their own job to do. But a redesigner can really conceptualize, work on the problem and really come up with a solution which can be implemented. Okay. So if you talk about the kind of cost of the healthcare in a country and even the other countries, it's very high. Every year, 60 million people goes into poverty, because of the kind of a very adverse healthcare conditions, and they are not able to afford it. Right? So if you talk about the PSCs, which really looks like this. Okay, well, there is a very less doctor, one doctor or no. So how we are going to live that? Many old age homes, very less doctor, no doctor. Yeah, and challenges are also here, like doctors. When the patient really comes to the doctor in such kind of a condition where they don't have any transport. In the villages, we don't have, in the go to the hilly region or in the land region, you don't have, the access to doctor is not there. How far are you going to travel? Okay, if there's a doctor, there is only some few facilities. Okay, right. So the level of healthcare here is like, we have the primary care essentials, secondary care specialist, and the tertiary care is like hospitalizations. We need to understand the system, the kind of a pyramid that we have, and the level of healthcare. And if we really understand the system, we can really pinpoint what sort of a simple autonomous systems would be required here. You're not always supposed to design a rocket. No, not needed. But design something which is really going to understand our need and would do the job nicely. So we can see the kind of the struggling phase we have, like. So awareness or lack of it, we don't have awareness. We don't have access of it. We don't have human power. In the case of we've seen the pandemic, what kind of a condition we had actually. We're so helpless in the pandemic. Okay, and affordability of the cost of the healthcare, because medicines may not be that expensive. The kind of infra you build up, the kind of delivery system you have that make the entire process very expensive. Okay. So we need to understand, if we really look at the kind of a direction to a solution, 3 doctors, Ravi Ganesh Venkatraman from CEO of Cloud9, and Dr. Astosh, Dr. Naresh Trihan, they have something in common to say. Dr. Ravi Ganesh says that it's necessary to find a ways to use technology to maximize their throughput without sacrificing on the quality and outcome. He's emphasizing on the use of technology. Yes, what is the technology and today? So we need to understand what kind of technology we are going to really leverage, and we are going to make something best out of it to serve the mankind. Okay? And what is the emergent solution that we have? So it's like, these doctors say it's key to have the private sector participation. Only government cannot do everything. The challenge is very, very large in nature. You need to understand, and there must be a public-private partnership to solve the kind of a solution, and there's alone one cannot do it. So technology is going to play a big part. Okay, it is the best way to achieve the vision of a connected healthcare ecosystems. Okay, so we are going to leverage the technology. Do we understand that? Yes, we do understand. We have the kind of component, we have the kind of capability in-house to innovate and come up with something which is going to assist you. Before you're really going to get a major kind of a health issue with you, do you really know the kind of things you can really get preventive or some sort of a thing? So, you have the key trends and policy interventions and innovation of the healthcare. And doctor says, we need to go for a much more matured digital base, okay, and effective policy interventions and with streamlined processes, because digital is going to really help you out in a long way. Okay. If you want to diagnose a kind of a disease, or you want to process the disease, you want to really go a deeper analysis, yeah, digital is going to help you out. We used to have a analog kind of X-ray system, but we have a DR systems. We have much more advanced CT scans. We have much more advanced MRI scanners, which can really make a 3D kind of a, scanning of your whole body and bones and nerves and tissues and everything. So digital is really going to help you out in a big way. Okay. So there is an opportunity for India to skip a full generation of transform healthcare and healthcare delivery using digital technology. And this is very much true. Okay. And we can really do a good job. Dr. Trian says, virtual reality, big data, Internet of Things, telehealth, robotics, and genomics are areas which will define the healthcare and exponentially impact the delivery to this masses. Yes, this is very true. And when we have such kind of things, and when we have the kind of a 5G coming into our place, I mean, we are going to really make this, we can see this going to happen in a big way, because we need this, we need to work on the kind of robotics and genomics and telehealth. Really, the kind of kiosk we are doing is sort of a telehealth only. You are sitting in a remote and access to a doctor in AIMS, and you are getting a kind of consultation from me, first consultation. So you're on level 1. So level 1, you can take the kind of consultation, buy the kind of medicine, and cure yourself. So what is the autonomous technology? Autonomous technology is any technology that can function and execute tasks without being controlled by a human. It's going to work of its own. Okay. These devices are physical form of autonomous technologies. Robots, both functional and humanoid, drones, and vehicles are a few examples of the autonomous system. They can learn from their surroundings and complete tasks without continued human input. They're going to sort of a program it once, and they're going to really do the job again and again, understanding the kind of a surrounding and the kind of, because they have sensors, they are going to really have a feedback system. They're going to have a the other kind of input output data, and they're going to control by its and do the job. So a short description of autonomous system. An autonomous healthcare service provide health expert, basically consists of hospital doctor nurses with the ability to access remotely medical and physiology data for many patients. The medical data is generated by by sensors and devices operating at the patient location or home, as opposed to be obtained in a doctor's specific hospital. We know that these kind of autonomous systems are really going to help us in a big way, and we must really they use different kind of sensor and devices to understand you much better. If you see what Philips has done, they have come up with the mobility, which really understand the healthcare on the wheels. Means really they are coming up with the concept, the kind of awareness which is going to in autonomous healthcare is like, but the doctor is not coming to you. I mean, there's a kind of a mobility, and this particular vehicle with a kind of assistance is going to reach you out and going to give a kind of assistance. And we have the other emerging solution which is going to come out like a doctorless clinic. This is somewhere in like Durgapur, when you can reach out these clinics and you can get all the kind of vital parameters done. So Meme Care Edge Doctorless Clinic is a self-help clinic where the customer can walk in to check their health vital stats and consult doctor through Meme e-consult. Means the awareness already started coming up, and people, not every time you're going to see the doctor physically because it's not possible. The kind of ratio you have is really less. So you need to understand what are the kind of interventions which can really help you out and can get the first-hand kind of information. And apart from the kind of a solution, these kind of solutions are going to have, suggest that someone says that we need to have a preventive or a promotive health, prevention, early detection and treatment. Yes. This must be a part. You don't wait for something to come to you. Rather, you get it checked, yourself checked, and that is going to help you out in a long way. Okay. So, there's need for this autonomous healthcare when not all the kind of things are performed by the human being. You really design a portal sort of a robot or a system or a technical system which can really does few things for you, which can going to assist you, because there's something routine which machine understand much better. Machine can do with the much precision kind of the ability, and then you have the solutions. So if you talk about the level of autonomy in healthcare, the left hand side you can see there's no autonomy, everything is manual. But as you move towards the kind of right hand side, increasing machine performed task. When you know that some task is to be like performed, you are going to move to the autonomy. Okay, and this is kind of a right. This is kind of an area which is like doesn't have a black and white, but something which is gray, something which like start something which partial autonomy and partial have the manual interventions. So it's like now you choose a path, and based on the kind of need, one must develop a system around it, and you have the solution which is going to help you out. Okay, so what are the essential component of autonomous healthcare? Is IoT is one thing which is important. Okay, Internet of Things, which are you're connected with different kind of a sensors. Blood sugar is again is sort of a sensor, pressure sensor, or you have the blood pressure, weight sensor, you have the heartbeat sensor, you have the smart pill boxes, whatever. They are all connected to medical services gateway, and they are connected to IoT and to the systems, and you are going to monitor these kind of things. So there's the essential component. We have the machine learning, artificial intelligence. We have the algorithms. So based on the kind of data we have, like it says that the healthcare sector currently generates about 30% of the global data. And these data are so valuable because based on these data you're going to write the algorithm. And based on the algorithm, you're going to have a kind of a pattern of treatment, okay, and the kind of benefits. So you have a connected systems. One device connected to several other devices, and that's how you depart to. You have the fact and truth belief. You have the reasoning networks. Okay. We have the formal methods, like if you want to have something communicating with the machines, you must communicate through some languages. You have the Java, Python, or the C, C++, and these are going to really communicate your kind of a thing, physical data to a kind of a digital, and then you're going to get some output. You have the counterfactuals, okay, which says that like it like that's the best example, like what might be true. Means if doctor asks like, what is not true could have been true. An expert doctor always do this, like they would anticipate something. So counterfactual conditions are conditional sentences. Okay, so these are going to again be the essential component of the autonomous feedback loop, which is important. Okay, we have the patient, the medical guidelines, where the patient codes, and then how you get the feedback system, and these are in the essential component of the autonomous system. Now, a few examples from how people have, how other countries have come up with a sort of kind of products, which are like, if you see a robot using AI and imaging to draw blood. If you want to take out the blood, you have a system which really understands you, which is going to identify the kind of your nerves, and you're going to really make a not a prick. There's something which a different methodist can take out the blood without making any kind of incision. And this is one device which is very new. Robotic doctor, we have the kind of surgical system that we perform. So again, with the kind of a precision, because you know that machine is going to do certain kind of a job. Okay, but at the same time, the man-machine interface and how precision, if you want to cut, because we may have a sort of a tremor in a house when you're doing a very precise job, but the machine won't have. Machine is going to do the right kind of a prick, right kind of cut, incision, and right kind of a thing which can stitching can be done automatically, because few things could be very routine one, very precision one, which manual hand and these machine manual hand cannot be doing such a good one, but the machine will do a better one. So, but about the cost of this machine, if you talk about this technology is fine, but what is the cost of machine? This is about 1.4 million, which is very expensive one. How many kind of hospital we can have the kind of province systems? Okay, so we need to understand: do we really need all of them as it is, or we as a kind of designers or engineers are going to innovate and come up with some alternative which are like native viable? Okay, for those things, right? So if you talk about this robotic surgery and which is mostly laparoscopic, because you're going to have a smaller incision, are going to have these kind of devices at one or two places. You're going to have a small incision, going to have the devices going inside the kind of body part. You identify those parts. They can do a small surgery and things like that. So that can do the job very precisely, but only the cost of the machine, which is varying between 1.45 million to 1.75 million, which is really expensive. And not all the machine, only I think of one machine, one system has FDA approval. Only one of the system has FDA approval, that the DeW. Other things are going to have, because we have a regulations. Okay, and these regulations are like going to be in place. So how autonomous system technology is improving the safety in healthcare? So you have the 3-4 points are there, like halting the spread of hospital-acquired infections. Okay, so you have, when you talk about the hospital, we have the different level of infection that can happen. I mean, these kind of systems, I mean, in case we have come up with a system which can really take care of these infections, and not a direct kind of intervention of the human with the kind of a patient, you are going to have a system which will play, or improving the hospital operation efficiency and freeing up the human personnel in the meantime, means you have the kind of a delivery systems. Okay, and you have this autonomous delivery system, which can autonomous delivery robots made by Panasonic, and this can really ship the kind of item from one place to another place, which very efficiently, or the risk of avoiding the risk of transportation of patient from bed to bed or from one ward to another ward. So can be done really autonomous technology. So there are some barriers to the autonomous in AI healthcare, and the 3 points are there, which are like federal regulations, and you have the patient and provider trust, and the ethics of AI-driven healthcare. So the other 3 reasons. And if you talk about the barriers to autonomous healthcare, so class 1, if you talk about the federal regulation, there are some 3 classes of regulations are there. Class 1, which talks about like minimal risk. Okay, so you're not going to get harmed. So you have something which fall under class 1, class 2, moderate risk, and the class 3, which is about like some high amount of risk to the consumer. And this is considered only 10% of it. So this autonomous artificial intelligence application fall on the class 3 only, because there's something which is new, something which yet to really gain a kind of confidence, and like you have the pacemaker or the other kind of devices which are going to really so critical. So that's fall on the class 3. So you have to have a kind of FDA approval in stock to like launching the product, or the patient provider trust, means how many kind of things we are going to really assign to the kind of to the kind of AI or autonomous, what is the kind of trust we have? Okay, because if you are going to have a system which is going to work on its own, and what is the kind of intelligence level that we have? Do we really need that? So we need to have a trust. We need to understand the patient and these kind of system provider trust, and that will help you. And the ethics of AI-driven healthcare. I'm not going into detail because there are terms which are not, I mean, I'm not so much familiar with, but these are really going to be the factors, 3 factors, which will help you. So why robotics and automation will redefine the healthcare sector? And we are almost at the words of industry 4.0 revolution. And we're in a area when we see so much of changes in the kind of situation we have, the kind of devices we have, the kind of automation, kind of things which are available in the healthcare sector. We just talk about 20 years back, and now the kind of devices we have is much different, much more digitally connected, much more kind of advanced, much more kind of doing job with a much more precision. Okay. So we are seeing the technology coming to a forefront and supporting us in a perform mundane, repetitive, and risky tasks. Okay, so we know that when we want to decide what kind of things which should be assigned to the machine, because some of the routine, some of the things will be very routine one, mundane one, repetitive and high risky. So all these are going to assign it to machine, and with the help of technology, with the help of systems, and things like that. Right? So the critical aspect of new technology in healthcare is like there are 6 kind of things which are very critical in to understand the new technology in healthcare. One is the AI, autonomous systems, blockchain, cloud and quantum computing, and we have the data analytics and 5G. So they are going to really impact on the new technology in the healthcare. So we can have a different kind of autonomous systems. Autonomous could be for critical care systems or intubation we have, or we can have autonomous circothyrotomy. There's something with emergency related to emergency procedures. Right. So we have several variants of this. Several kind of translation. You have the cardioversions for patients with arrhythmia, irregular heartbeats. And this intervention procedure in autonomous intervention procedures. The coronary angioplasty and stenting of arteries. This can be again done through autonomous intervention procedures. And likewise, we have the other 3 or 4 of them. Right? Okay, so medical autonomous system can also improve healthcare delivery to a great extent, and we have to see the days when all these things are really become a reality using the autonomous systems. So if you talk about the example for the industry, like autonomous robocar, and like we have these healthcare, especially related to healthcare, and these cars are especially designed by someone to perform some task. And if you have this kind of injections, if you have this robot, it's a very nice robot with senses, autonomous robot utilizing the company Kobe's platform to perform injection without using needles. Okay, injection without needles. So this is going to scan your body part where the kind you are going to take injection, you're going to apply some kind of a swab, and you have a proximity. It all guides you and a very precise. I had a video, but I can't play it here. But this very interesting and very precise one, because it really take the injection from somewhere, apply to you precisely. Without any kind of needle, and then place back the kind of other reuse part, right? So we have another is like autonomous cars, means they are like something where these audio icon has done this, and they are on demand healthcare system in form of a self-driving clinic. It's a small clinic. You would just board into it, and it's really, while taking to the hospital, it can going to scan you or all the vital parameters. You have a small kind of a clinic inside, and you have a seat. You can get the things done, vitals checked, and by the time you reach the hospital, you have all the parameters checked, and you can have a consultation with the doctor as well. So we are in a kind of situation when if we don't do this kind of innovations, we're really going to put in a lot of burden on the kind of existing medical systems, and one need to have to leverage the technology and the things which are readily available to us. Only thing we need to conceptualize and come up with the products which have a combined things together. Even after consultation, we can take these kind of medicine approaches and we're going to give ourselves. So this how the designers abroad are, they're working on, they're identifying the needs and they're working on it. They're working with the doctor in sync, they're working with the hospital staff and the medical system all together. And collectively, they are going to come up with a solution which is going to give us solutions to you. So wise solutions. And this is very interesting to know that there's a funding to create an autonomous robotic trauma center by, this is a US department where it's going to total like contract is for $7.2 million and things like that. If you have to really, transport your soldiers from battlefield or some that kind of situation, what kind of this transportation must be there, which while transporting, you are going to check the vital or check the kind of other, give him some kind of a first aid to the patient to save the life of that person there. Some example, like you have the disinfectant robot, which is autonomous thermal fogging machine, like you have it's going to scan you, it's going to actually spray the fog and you're going to disinfect you. The world is doing what we're working on. And this is again something which is like, FD has just approved this 2018 only. So, and this for retinal image, this to detect the diabetic retinopathy and something with, so FDA has given approval to this system. You have the Riken RoboBear, which is going to help you out in transporting the patient while taking on a wheelchair or from the bed to the wheel or wheel to the bed, likewise, and very efficient one, something very simple. And you can have a system like this. Again, this you can see the right hand side image. When the doctor is consulting with the patient, doctor is physically not here. I mean, this is like something which is telemedicine. We show the doctor, we show the kind of other kind of a hospital staff which can help you out in taking some of the vitals, and you can have a direct consultation rather than a doctor visiting you again and again, and the kind of time lapse we can consult you distally. So all this about the kind of things we are the world is doing, and what is that we are going to do actually for our system and our country. And not every time, as I said, we need a very large, very complex systems, but just see the patient which is there on the bed, and if he needs some assistance, can we really think of him? Okay, can we design a mobility or monitoring or reminder or care or something which is very cost effective? Because you think simple, and that simple thing is going to work out really good, very cost effective. Right? So you have a kind of a very routine kind of a thing with every patient. You want to check his kind of this blood pressure, or you want to have heartbeat or temperature, or those things, you can be assigned to a machine. Okay, and that's going to really come to you directly and do the job easily. So we need such smaller systems. Okay, we need like a distance monitoring with infrastructure limitation. Like we have a patient, again, something which can really sense or monitor or track the alarm or care, or something which can really alert you. Very simple devices, not very complex one initially. Of course, we need a complex one as well, but one. So adoption of technology, like we can have a partial automation, can give earliest, and then later with the learning it can be moved to full automation. So we are going to have the not everything very fully automated at this point of time, but can we have something which is like really smart enough to take up the things which we want actually initially, and slowly move on to the full automation that helps out. So what is the takeaway for this particular workshop is to deliver adaptive solution by keeping updated with the technology to serve the end user, whether it's a patient, and a hospital or healthcare staff, a helper or maintenance person, and following the context for a developing country in mind. So we need to understand our constraints. We need to understand what kind of audience, what kind of a user you're going to work with. We don't have that all the resources that we have seen earlier. We need to understand, we need to be smart enough. We need to be really realizing the real need, and based on the real need, you're going to work on it and come up with much wider, smarter solution which can he'll help us out. So, I mean, this is the idea. I'm just thought I should show the picture to you. I can really find, I can see a very good mechanical engineer, a good kind of automation engineer, or AI engineer, and electronic engineers, software engineers. All of them are within this kind of a group only. And if we really need to come up with something really wise and good, we don't need any superficial. We need only a simple average person who's passionate about the work, and we can really come up with a much wider solutions. And I'm sure with the kind of talent we have in the country, we can successfully design, develop, and have a need-based product to serve the healthcare sector. Okay. So this is like the end of this presentation. So any questions we have, I can take it up. Thank you so much.
Thank you, sir, for this enlightening session. We have a number of questions from the audience.
Yeah.
Question number 1. How can we reduce the fear of hesitation in patients while dealing with large advanced technology machines through design?
Yeah, I mean, that is really, whenever we design any product, first of all, we make the product really looks, first of all, in looks wise, we make the product look friendly. Okay. If you talk about the aesthetics of the product, we don't make it look something which can really fear you. Okay. So we design the product in such a way that you see only the softer aspect of it. You see the kind of a product which as a whole is very cool, calm, subtle, confident. If it's designed well, you'll automatically gain a confidence. If it's not designed well, you will always have fear to go to the kind of product. Okay. So the way you have shown the kind of a defibrillator, yeah, that really designed well, that give you confidence. This is going to perform a good task. That is one thing. Apart from that, we have other psychological reason which I won't be able to answer. But from the design angle, yes, we want to make the product. We always make the product very safe and sure and a friendly manner.
Question number 2. What is the feasibility of applying these emerging technologies in rural areas, considering the high cost of implementation?
See, high cost is what? Is the technology cost so high? Not always. Okay, so what we need to understand. That's why I really covered several times in the lecture. It's like we need to understand our actual needs. Let's not be carried away by the kind of what other people are doing, other countries are doing. We need to understand if we want to lift a patient from the bed to the kind of a toilet, how simple we can do that. And that is not a very high technology. You need to understand how simple. And here, what happens, like, only the frugal design really works. Because no designer go to that level and work, spend the time there. We need to understand what do we need and just solve only that particular need. And that need not every time will be so expensive. Now, what happened, like, if we talk about like resources, now the government of India is also giving so much aid, so much kind of a grant to the kind of a new innovations. If you really identify a good need, the money is not a problem. Okay, that can be done, that can be solved. And that if you're really working for the rural, you get an extra advantage from the government. They consider if you really have a good wise solution that is going to cater the masses, you will find many of the investors, really putting money there. We don't have that kind of a bottle now these days. Yeah. Only thing is why we designer need to understand that and join hands together, because one person cannot do all the jobs. We'll have to team up. And we'll have to really identify the good team of people who live with the like-minded people who can join the energies together. The average mind can do a great job. Thank you. Next.
Third question. Given the technological advances, can we expect medical institutes to hire designers in the near future?
They should actually, because, they are working in isolation. They don't understand that we designers are so versatile, because we are a problem solver. Okay? We understand much better than if you really you can really brief us what is to be done. We are the best people to understand and really solve that problem in a very systematic way. Only thing the doctors, they don't have time with us. I've tried so many times to get joined with many of the kind of the bigger hospitals, but they really don't have time. There could be a wise solution, and I'm sure, and I really advise all these big hospitals and the doctors, they should devote some amount of time with industrial designers, especially with industrial designers and the product designers. And I've seen so many good examples out here when the designers have created a first time ever products, very good product they have created, which was like, never was there in the kind of market. In the kind of a product which I have done one, it's like man-mounted air conditioner, which wasn't existing ever. But I've worked with the kind of a scientist, I've worked with doctors, come up with something really good, and that is really solving a problem. So we need to, the medical profession need to trust us. They need to not only imply, they should partner with us, and that's the kind of change will happen in the industry.
And the last question from our audience, sir. How do we empathize with the user when designing autonomous robots?
I need to understand that, yeah. I need to think to give answer to you. Okay. I don't have a ready answer, but it would be a good answer. Let me think. Okay. Sorry for this time. Yeah.
No, it's okay.
Okay.
Okay, may I chip in?
Yes, ma'am.
Yeah. So thank you, Mr. for a very good insight into how autonomous medical care system can be generated for 21st century. Like in pandemic, we already saw that remote consultation, and the same. Why can't we take it same like this again was disruptive? We did not thought maybe 2.5 years ago that we'll be delivering lectures through this Zoom and other platforms.
Yes,
remotely.
yes.
Nobody has thought of, actually, at least I have never thought of. And you brought us to that, nostalgia when you showed us the classroom of ours.
Yeah.
Okay. we are deprived of that last 2 years. But yes, if that can be happening because of this pandemic situation, why can't we bring that kind of disruptive technology for the healthcare system? As you rightly pointed out, we do not have in villages even primary health center equipped with the doctor and nurses. There is a compounder kind of person who is only giving away the medicines because government is supplying. So why can't there be like internet connectivity through the Zooms? Doctors can be connected. They will have simple primary consultation. They will ask them to go to secondary center where there might be a kiosk kind of self healthcare center. They will get some diagnostic done, and then they will share it with the doctors which are at the level 1 kind of city kind of hospitals. And they get diagnostic, and then they will be told that okay, you require this kind of surgery or this kind of treatment, and then they will be only going once to that center, right? Otherwise they have to go to and fro for each and every of these steps. The thing is, you rightly pointed out, why can't we do that kind of situation which is required at this moment as well? So that is very, and again we saw this drone like of unmanned vehicles. They are giving away the medicine or the 11th hour emergency kind of medicine or treatment through the drone. So those technology is not away, decade away. They can be brought at this moment as well, because already we have developed that kind of technology. My small question is, see, you have given example of inventory system or some such system where safety is not that important. So if a robot does some error in the inventory, there will be inventory kept in a store for, let's say, longer. So it will not be just in time system. But the robotic master slave, if that brings some trouble in the surgery, right, then there can be a patient's life. No? So what is the level of redundancy we require in all such automated things, whether it is a surgery or any type of something where the life, like autonomous car or autonomous train, number of lives are actually at stake.
Yeah. Yeah, I think you're right, perfectly right. Only thing, the kind of the level of the level of confidence that we have on the new system, because आप अगर देखेंगे on the any kind of a CNC machine which is working and doing certain kind of a job, is assigned something which does perfectly. Okay, like the kind of error a human can make and a machine can make, a lot of difference actually, a lot of difference. Error can happen with a human. Human does a much more error than the machine. Okay, so we need to give a chance. We need to really rely on that. The moment you ride an aircraft, okay, you are in the hand of a technology. Okay, you're in the hand of a technology, and you'll have to trust that. You'll have to trust that. See, so much of kind of situation has happened. So much of kind of safety measures they have taken in different aspects. Still, there are kind of errors that happens that you will have to take for granted, because because if you really say that one error happened in aircraft and aircraft crashed and you're not going to use the system, no, that you didn't have to really move to the next level. So that's how you will do some one thing, take it the technology to one stage, again test it out, validate it, again move to the next stage with a greater kind of confidence. That's where step later you take and achieve the kind of a perfection. So it's like in a machine which are like an unbiased one thing. Because doctor may have maybe like doctor performing an open heart surgery may be really tired because of already has performed so many operations. Machine is not tired. Machine is never fatigue. Machine never get tired, and machine can really. So we need to trust that. We need to really have a feedback system, to improvement system, continuous improvement system. That's how we should trust. That will take time.
Yeah, and that might the kind of redundant system I'm talking about, that actually makes the system's cost higher.
Yeah.
If you want more dependability in the system.
तो अभी हमें करना क्या है डॉक्टर तनुजा कि we need to really, मैं बार बार repeat कर रहा था, we need to understand when not always we need kind of a Da Vinci robot for every kind of thing. No, that is the ultimate. But we need to understand what other simple things we should innovate that work on an autonomous mode, which is not very expensive and really help you out in mind. Because हमारे यहाँ क्या है, we have a lesser kind of manpower who are skilled one. Earlier we used to get a lot of skilled manpower, but now no, don't. People want everything at the press of a button. Okay.
Yes.
Everyone. So we need to understand that we have that lack of skills. At the same time, we need something which really is a very simple job. Because I had a patient who was not able to move, and we have a system which can really take him from the bed to the toilet. Even that is a task, amount of task. Yeah. So we need to understand these small things first compared to the very last kind of a. So this kind of a journey.
It reduces the caregiver's effort as well. So that is also a huge
yes, a huge effort.
Yes.
Yeah, huge effort. Yeah.
Yes. So any more questions are there? Linda?
Yeah, there are no more questions.
Okay.
Thank you, sir. We will now move into session 4 on building cost-effective functional prototypes.
Yes. So can we start right now?
So do you want a few minutes break?
Yeah, 5 minutes break is, 5 minute break should be okay.
Yeah, at least you please have a cup of tea or water. Yeah, that is very much needed actually.
Okay, no problem. Yeah. Just give me 5 minutes. I think this
5 minutes.
It's 4:33. I think we can start at 4:40.
No problem. No problem. Yeah, you need that.
Okay then. Okay then.
Actually, you earned that day.
Okay, thank you so much.
Please.
Thank you.
You can start a video by that time.
Okay, thank you.
acting like a maniac and I don't know what's going on. Now all the love within my heart is flowing like the Amazon. 'Cause in the wild I was getting drunk with something I don't know. Oh mama, oh yeah. The queen of love promised me that I'd be fine by tomorrow. Oh mama, oh yeah. Oh mama, oh yeah.
Welcome back, everyone. Now we move to session 4. We encourage the audience to please post your questions in the chat box. Thank you.
Over to you, sir. Thank you.
Over to you.
Okay, good. So let me share my screen.
Yes, sir.
Hope you can see my screen.
Yes, sir.
Okay, good. So the topic here is like building cost-effective functional prototypes for the new design of medical devices, right? And if we really remember, in design, I've already mentioned that design take not so long a time, but engineering takes some amount of time, but the prototype take a very long time. And you're not going to make only one. You're going to make many of them and many kind of iteration and refinements before you use the final product. Okay, so prototyping is really a much more kind of elaborate task when you need a really good working prototype, markup and soft markup and hard markups and the prototypes, working prototypes, functional prototypes, those things. We can see that, and really in my company I have been really emphasizing more on the prototype because again, as I said, the companies who really from whom we do the consultancy and give a design, they need prototypes. Without prototypes, the kind of design is incomplete. The kind of data, the kind of thing I want to communicate is not the same. Only through the kind of a CAD and the render images. So, but this is a kind of a challenge. Okay. This is something which need a kind of consistent effort. And especially when we don't have a really good prototype makers in a country, because people are there who can help you out in one function, but collectively one at a place they're not there, not a dedicated system or not there, and they are so reluctant to really making one-off kind of a thing, because design is always one-off kind of a thing, and that take a really good time. So let's see that how I really handle the situation in my professional career, because I've been running my company for the last 16 years and always I face the problem and how I have solved that, right? So first of all, what the question is like, if you talk about the design phases, we have 4 phases of design, wherein the first phase is about research, second phase is about product design, third phase is about like engineering, and the fourth phase is design phase 4 is about soft markup and prototyping. Okay, and what is the purpose of a prototype? We need to understand that. Okay. So to get actual tangible feel, because everything so local, it looks scaled up. Okay? If the product is so small, you're going to see it on a larger version on a scale, in a screen, computer screen. If this product is too big, you're going to see the scaled down version of it. So there's never the kind of honest to one scale, very less time, so that you, first of all, you convert your ideas into a 3D model, and that is necessary. You want to make a soft model or a kind of, you want a hard model, whatever. You convert that into a physical object, which is 3D. You're going to touch it, feel it, and those kind of things. And test an idea to see if it's really working. If you want to make a working prototype, you can see that, because prototypes are time taking or iterative or expensive, but you're going to make one for yourself, and you're going to see, fit in all the internal components and see that whether this prototype and the product is working fully or not, if any kind of interferences, because while doing the kind of a detailed engineering and CAD in 3D, you may miss out some of the points, on which we do actually. It's never 100% correct, unless until we have really made a 3D prototype, either 3D printed or you have the kind of a manually fabricated, you're not going to give a go ahead for the mold making, right? And third point is like you test the design to see if it passes certain kind of requirements. Because if you want to attain a sort of a weight constraint or a kind of a dimension constraint, or the cost constraint, you can really test it out at the prototype level. Okay, you can see the basic and the required functioning of the product at the prototype level. If you want to make a change in the prototype, that is possible. But if you want to, we have started with the mold and you want to make a change in the mold, even that is possible, but incur a high amount of cost. Prototype won't be that expensive. Okay, used to evaluate whether improvements are necessary. Okay? So you know that you make a prototype and you want to evaluate it. You want to evaluate by keeping the competition product besides that, and we can compare how it's bigger or smaller, or it's looking like really what kind of attributes you are able to see that. I remember doing a kind of a range of refrigerator for Whirlpool, and the new design prototype, which is as immaculate as the real product, they're really kept in between the kind of other competition. And user is supposed to look at the kind of the design which is the new one, and only when he is selected, then the design is selected. It's very rigorous kind of a method to select a good design, and we have really followed that, right? So moving on to the next, like it's not only the kind of prototype maker. This particular image is from my design office, and you can see that engineers and designers are working together. Even I really get involved into the design process, making of the prototype, because this is something which I have conceptualized. So if I have conceptualized, then I know the best what is I need, because drawings may lead you to somewhere else, slightly somewhere else. Because design is something which is very fine line, may become slightly more fatty or more taller or more fat or more shorter. So one need to really know that what is I really intent I have. And this is how there's a typical setup of a prototype, which my friendly company has in Delhi. And you can see the product on the white here, which is being made. And we have the several dies. These are the dies. They have the several pieces like in a fabrication process. So you get it done by a fabrication process. You make the kind of a dies, bending tools, and thermoform it, cut and paste it. And that's how you get a kind of a product ready. So it's very time-taking process. Manual is very time-taking process. But if you go for automation, that is something which is like very expensive one. So I mean, even though you won't get the right kind of a finesse and quality. So you can see again from my studio only, you can use sort of kind of a material like you have the pipe, you have the other cutting tools, so you have the sanders, you have the the kind of cutter tools. Here, not a very elaborate setup, but a small setup with some kind of a basic machines. One can really start with the prototyping, and that give you a real good picture of your design. Because if you get a hands-on making prototype, that's the best way to improve your design qualities. And I really must say that please get your design made through prototypes, and you try to make it by yourself. Some of the softer ones, or you involve in the kind of prototype maker who can assist you in cutting the harder material and those things. So this was finally made one day. Very long process. You can see the kind of a dies here. They are thermoforming dies, and these dies are going to give a shape to this one. You're going to heat the sheet, you're going to form it, and that's how we get a kind of a larger piece. It's not machined, it's like all handmade. And handmade is something we're going to take a time. But if we're going to machine one, which is machine can do the same job. But to mill a kind of a part like this from a solid kind of block of ABS may cost you say 50,000 rupees. And the entire product here, what you see is made in 50,000 rupees. So it's very cost effective means, and we have a challenges here. We have a kind of a resources, the skill manpower and those things, but we still able to manage it in very cost effective way, prototypes. Okay. So what are the prototype facility that we have within our country? If you need to know that, large companies, they may have in-house setup. Okay. And they develop many products in a year. Like if you talk about Mahindra, you talk about Maruti, you talk about LG or Samsung or Whirlpool, they have, many of them have their in-house facility, small or big, whatever, but they are able to make the prototype in-house. And that's how they can secure the kind of confidentiality of the kind of a design. The design is newly created. You're not going to share with anyone. Okay. And within the house, that way your design is confidential. Smaller companies, they outsource, whether that is a manufacturing companies or a design house, they outsource. Even we as a design house, we just built up because we saw that kind of a problem getting the things done from outside, and we maybe a threat of getting that design leaked, we started in-house, and that's how we do it. And prototyping vendors are very less. If you talk about other countries like Japan and China, they have prototyping, dedicated prototype makers and their companies who really does a professional work. They'll have all the kind of facilities in-house on the one side. But here in we don't have actually, and very few of them, they're very small and they're very, very small. Okay. So we need to, there is a need of a kind of good prototyping setup, which can help the designers and the creator who want to convert their design. And this particularly we learned, I mean, this I'm especially showing because this is my NID course in way back in 93, 96. And unless until we convert our new design into a prototype, we are not given a word, we are not given a complete for that particular subject. So this solar water heater was actually a functional prototype, which was made by my thesis kind of a company from where I was doing the thesis. I did the design, I made a small mock-ups and all, but they converted that with my kind of supervision. They converted the design into a real working piece, a very big size. It's almost like 6.5 feet height and 8 feet long, and those kind of complex product. It's a solar water heater. But the things you see on the right hand side, like a handrail, which is actually carved out by me in NID using different kind of machines in a wood, and that is the mock-up. There's not a functional one, but if you want to see the form, this is the only best method. Nowadays, we can, this product like this small, you can get it 3D printed within a daytime. Okay, but those days, I'm talking about 93, we didn't have 3D printing machine. So we were supposed to do by our own hand, because this form is so subjective. Like when you start grinding it, you start cutting the wood, and you will come to know where to stop, like where the form is started emerging, like really good one, which machine may not. So initially you do the kind of a form by yourself, and that's how we learn to do the form. And the other product, the mockups also, they are in scale down versions, but really made a good prototype. From where I really learned, if you want to really improve your design skills, one must make a good prototypes. Example from industry here is like oil chaff cutter, which I've been showing to many students here. This is like a chaff cutter machine, chara cutting machine, and you have the exposed gears. And to cover that, they have a ready product like an oil cover, which is again made of cast steel. And this very heavy, 7 kilograms, top and bottom part, 2 parts. I said plastic can do a really better job, and we design it well. We made and fitted to one of the kind of chaff cutter. You can see the kind of a design difference in both of them. And in terms of weight, and in terms of like a look and feel, the geometry, the overall appeal of the product, this is really way out too good, compared to that. This really, if you convert the rest of the chaff cutter, that may even become better, because they took only this part. They said, this plastic can really do, and we made a prototype, and this prototype was made manual fabrication without any sort of dies and all by my prototype maker, using the kind of a PVC pipe sections. I took, I think, around 2 or 3 days to make this. To make one of such, we actually fitted into the one of the chaff cutter. We shown them that this is how we're going. Only when they have shown, they seen this fitted, they got convinced. Otherwise, they used to tell, this is not going to work. Okay, and this is very light in weight, unbreakable, easy to manufacture. So many other attributes are there with that. So this can really help you in convincing any person that you have really made a good piece of work, your design is really going to work. And some of the companies, they believe only in something tangible, not on a computer screen. They want to have a feel of it, and that's how they get convinced. So if you talk about soft mockups and prototypes, what are the kind of methods that we have? What are the things we need? Like in prototypes, we soft mockups, hard mockups. Soft is something which is made of thermocol or made puff or paper or any kind of a material which is soft, which is very fast to cut it and make it. Hard is something like you make something in an MDF, plastic or metal, something. Clay model is, industrial clay. Like you want to make a form for a car or a bike, yeah, clay model is one. POP model, plaster of Paris model. Yeah, if you want to have a very intricate surface or a transitional surface, you want to good quality surface, POP is a really good material to work with, very cost effective as well. A POC kind of prototypes, okay. So we make a certain portion of the prototypes when we want to prove only certain kind of functionality of that part of the system, and we go for POCs. Non-functional prototype and the functional prototype. As the name says, like functional is going to work and non-functional is not going to work, but it can house all the components. Okay, it can demonstrate that this is going to house the component, but it is not going to function and demonstrate. So the limitation here in the prototype is like, first of all, a very few prototype manufactured in our country, which is like a good amount of gap. And if you really coming with the new product, you just move here and then find out our right source where to get it made. In terms of materials, we use thermocol, rigid puff, wood, MDF, sunboard, acrylic, aluminum, mild steel, all these materials, whatever you can see it here. But only thing we had, there's again a limitation of the wide variety of material which are available. Okay, we have a limitation here because if we want to get a very good kind of a texture, kind of a sheet to apply a texture and show that we don't have. So we need to really innovate on the other front, because if you want to make a prototype, make it so impressive that by looking at the prototype, the design get approved. Okay. In terms of processes, we have the first of all tool, manual or power tool if you want to use it, and 3D printing. Yes, 3D printing has a limitation of size. Like you can't make a product make a 5 feet long. Okay, so that is a kind of limitation. Again, the cost of 3D printing is very high. You go for SLA, which is very expensive, compared to SLS, which is affordable, and FDM, which is affordable. But the kind of finish you get in SLS and FDM is not that good. SLA is something really good, just like a molded piece, but very expensive. A small piece of say 1 inch size may cost you 10,000 rupees, which is out of reach of many. Okay, we have CNC laser for 2D kind of a sheet cutting, thermoforming, vacuum forming, CNC milling, turning, shaping, grinding, FRP, fiber reinforced plastic. So these are the processes which can be used in the making of any of the medical equipment parts. And we need to know that limitation, and for the vendors, we need to identify, pursue them to get your product made. So limitation here is like in a company, the vendor are reluctant to take one-off job, because whenever there's terms called R&D comes to mind, people are so reluctant. They don't take so much interest. So even for the CNC machine also, if you go to a CNC machinist, ask him to run only 2 parts, he won't be interested. Okay, because he need to program that machine. He need to find a slot in between that. So no one take a one-off kind of a job. That's kind of a challenge we have when we really deal with the prototyping of such things. And very good example here I saw that what does a soft marker does actually. We were in China and we done all the CAD for a patient monitor, a medical device, and one thing you measure something and come to know this is of certain size. Another thing is like if I look at it, when I saw the model, I found something wrong with the kind of proportion and the scale, and that was really very bigger than the normal kind of thing. I asked the company to make this kind of quick thermocol model. And when they transformed that design, 3D CAD design thermocol, you can see the size on the right hand side. This was the actual size which was there in the CAD. And they were about to, go for a kind of, the mold development. If they could have, the kind of mold prices, because the sign increment and the, all things, it would have been a disaster. But this small size to convert that 3D model step file into maybe a rough block of thermocol has saved us actually. So always please don't take things for granted. I think I suggest all the engineers and designers to make a mock-up. Either you take a wood, either take a kind of a thermocol or a plaster of Paris or a kind of paper model to convert that into something tangible, because computer may give you some kind of other illusions. So thermocol is something very, very, very cost effective. very easy to cut and make it. Only thing you won't be able to finish this so good. You have a different thermocol in different densities, and some of the grains which are like really bigger one, that like very loose grains, and very compact one, really hard one. So you choose what things which are available. If you want to buy a hard one, you may not get at all, okay? Because hard one you can give some sort of a finesse, right? So you have to look for some good quality of thermocol, and thermocol dip into a plaster paste can give you a product on the left hand side. So you have really made a good piece, and if you dip it once, two, three, several passes, you a layer by layer formation of these the POP will happen on the top of thermocol, and that's how you can get a good. But these are like very messy process, and nowadays very few people use it. Only thing is those who have cost constraint and have a good amount of time, they can use it, right? So Puff is again a very interesting model, because I've really done a lot of product in Puff, because design of all my microscopes, all my refrigerator handles, all my kind of washing machine parts, I would have worked on this Puff really in a long way. And this is the best, one of the best model, because this comes in a density of say 45-50 kg per meter cube, and not that expensive. One block may cost you something like 500 rupees of 4" by half meter by 1 meter, 2 meter, 1 meter, yeah, and that is so affordable. You can manage it, and you can take you need only kind of a handsaw or kind of a cutter and a super glue. You can see it here, a super glue. This is going to join the pieces together. So this just like something which is a rigid puff. It's a puff, is rigid foam, which doesn't compresses, but it's a very solid one. You can take a hands-on, cut it very easily. So one has to be really careful enough to make a form. This is again a medical product, and need, because this particular client was so much like they said, you give me the sketches, give me the 3D model, and the puff, your job is done. Because all these only three steps are needed, and we have been doing all the steps for all the product for them. So this gives we made one model. This took around 3 engineers, one designer and 2 engineers. We took almost 9 hours to complete this complete model, this model. Okay, and by the night 9 o'clock he came and he approved. That's because one need to really compare in terms of like overall physical shape and size, in terms of transition of surfaces from one surface to another surface. And this is a really good material to give a very good idea. See the kind of transition here, very good transition happening from the back portion, this portion, and this portion. These are like design portions. So one can really make it out. What the thing what we're going to is really good. It's not fat. It's not so slim. It's not become so weak. All those things. So you can take almost like a 90% almost correct decisions, and then he can really move on to the next stage of making the models. So you can see the processes. We have the very common tools. Here you can see the files, the brush, the tri-square, the cutter, glue, and the sellotape, all those things. We convert this into a 2D drawings. It's not shown here, but these are sort of a template. These are templates which are like, we cut a profile, take it 1:1 print, take a profile, just match it from the sides of it, and grind it very slowly. You can see this kind of a tool which are handmade. These are having a sander on the other side. You have the sandpaper of 200, 300 different kind of a grade. And you do it very carefully. If you don't do it carefully, it's going to really overcut it, overgrind it. One has to be really careful in doing that. But this gave an awesome result in some time. Initially, it's very time-taking process, but now, and you always wear a mask, because this is something which the fine particle dust comes out. So if you wear the mask, dust particle is going to go inside. So this is a fantastic material to work with, and you can see that how this was a kind of a benchmark, a Chinese kind of microscope, and this is what we developed actually. And this has got one of the red dots. Okay, so this is how we compare when keeping these things together. We're not going to copy anything from here, but we need to compare if we need to really understand the size and proportion and the eyepieces where this is going to be there. So you can really place this particular microscope of model on the table, and you can sit in front of on a chair. You can really pose as if you're going to see it. So you can take all kind of ergonomic consideration, like where the knob is at the right place, the eyepiece is really at the right height, and those things. So this gives you all kind of a freedom. And this is, you can again see all my tools. Okay, this I just finished, and all my tools is kept here. This is not a tool. The entire tool will cost you like 300, 400 rupees. That's all. But you can really do a very good job. Only thing one need to be consistent and while puffing it. And this is done by designer, not any kind of any kind of other people who are craftsmen, because I understand what design I have created and I'll do it myself, because all these surfaces are under transition. I just really take a larger surface, a broader surface, cut it very slowly. I just enjoy doing that. Okay. When I really achieved some sort of a perfection close to that, I start sticking the paste, the different components together and convert into one kind of a model. And next important is like in a paper model, which is again hardly any cost, but within with very less amount of time and effort, you can really make a good quantity of paper. Only thing, paper is something which is 2D kind of surfaces. You can't make a 3D surface out of it. So paper is really good. Any camera, you want to make a cube or cylinder or any kind of a thing which are not having kind of a transition of surfaces, it can be made very easily. And I need to learn how to cut a paper, how to cut a circle and all things. How neatly you cut it. You have the different quality of paper you have. So this is a very cost-effective and very fast way to convert into a markup. A size like this one, this is like not done by paper, but if you have this kind of a shape, it can be done by paper. In case you want to cut a paper using lasers, one is kind of you take a scissor and cutter and do it. Another thing, you take a laser and do it. Okay? Laser can be done with, so not very expensive one, but you can have a very precise cut in the kind of piece of paper you have. These machines kind of available. You have the paper model like your stencil cutting machines. You can cut the kind of shape and profile, and you can just go into paste it. A product like this on the right hand side, like a bicycle, it can be done in a paper. Apart from the wheels which are 3D, all the parts which are 2D is can be done. A cylinder and a cuboid and all those things can be done in a paper. And then things which are in 3D take off other materials. Okay, so this is a combination of material, because you are going to make a model. Unless until you make a model, you are not fully convinced. When you make a model and you fit in the internal component, then you are 100% sure that you're not doing anything right, anything wrong. Okay. So they are very method to cut the model and paper which is interesting, but not this kind of form which are a 3D and 2D forms. 2D form can be done in paper very easily, but wherever I written the 3D, you're going to use a puff. Okay, puff or any other material. Okay? You can use a POP or a paper model, but POP is heavy, paper is so light. So ideal is to take a kind of a puff and then take a kind of this paper together. And this again stencil cut paper model. If you want to do a package, you have the stencil on the right hand side, which can really cut the paper in the size you want. It can make a crease and then you how to fold it to make it kind of a package. So now coming to the important point here, like vacuum forming. Like vacuum forming is something which is like suppose a large machine like CT scan or MRI machine. How these large parts are made actually. If we talk about this diameter will be about say around say 6 feet in diameter. The hole will be about say 3 feet in diameter. The other portions are like in a very large one. They're not injection molded. If you really go for injection molding part, that size of tool will be so difficult to handle. And you don't have this kind of machine made in millions of pieces. No, you just maybe 100 or 200 pieces. No, I know. And if you see this smaller part, they could be managed in injection molding. Handle is injection molding. This is the injection molding, because these small part can be managed. So product like this on the cath lab on the right hand side, you see they are larger medical equipment. Okay, and these are like part come out of the vacuum forming, thermoforming. Okay, so you're going to have a sheet of ABS, you're going to have a sheet of HIPS or any other sheet which you want to make it. And you heat this, you make a kind of a pattern first, finish the pattern. Patterns are there, or in like you have the MDF pattern or you have the aluminum pattern on top on the pattern using the kind of a machine, vacuum form machine, you're going to vacuum this. So you can see this part of vacuum forming, how they start. Everyone knows that, very simple to understand. So you have a sheet, we are going to heat the sheet to a certain temperature, it becomes softened like that. And you have the die below, and on the die, you're going to vacuum this. So this vacuum part will going to take the shape of the die, and this very simple process it can be applied to a smaller to the very bigger part, and the part is going to be strong if you're going to take ABS as a material. I've seen the kind of cath lab, these kind of cath labs, all the parts are made using the vacuum form, even the vacuum forming for this MRI machines. This I saw in China, wherein people are going to, all the 3D shapes are going to get from the vacuum forming, and the rest of the cut and paste method, like manual fabrication process. You do a CNC laser cut, you are going to bend it, and you're going to glue it with the kind of glue they have to join the ABS and sand it and finish it. Okay, so all these processes are done manually. that is the most cost effective, because if you go for a CNC all part is going to be super expensive. So this is a typical vacuum forming machine. On the left hand side, you have a kind of a cavity when you put a kind of a mold there. On the right hand side, you can see the mold and how the sheet has taken shape of the mold. So you're going to heat the sheet. This is the top part is the heater. You're going to use the heater, and heat the sheet, and the sheet become really softened. You blow the sheet first, and then you vacuum it, and it's going to take a shape of the kind of a die. It's a very cost-effective. I've seen many of the companies are doing bigger part in vacuum molding. That is something very cost-effective. That is something feasible also. If you see the internals of any refrigerator, white kind of a layer you see, that is a vacuum formed part. Even in the door, even the kind of inner liner of that refrigerator, they are vacuum formed part, because these are no other process can really get that thinner part and that stronger part using injection mold. Injection mold will be way too expensive. That's not needed. So I've discussed about this handle. I mean, this is the old handle and the new handle. Unless I really made this handle in a carved MDF. This was not MDF, this was solid wood actually at that time. And I've really used the solid wood to carve it out slowly, and took almost like months to complete that. And even painting also, like 2-3 iteration to really paint. But the kind of detail I got in the solid wood is really good one. I applied the paint several times, put it several times, and then I got a very good shape for carving out. And apart from this, if in case you want to have a subtractive prototype, you have the milling machines, and which really take any wood as a kind of a material to subtract it, wood or kind of acrylic or ABS. So if you want to make certain kind of say low volumes, yes, they are like something which should be used. Otherwise, if you want to have a really molded one, the same acrylic, they are going to invest in dyes. You want to make one off or two off. Yeah, subtractive is one thing which can give you a kind of pattern. That pattern can help you in making the FRP dies. And with the help of FRP die, you can make a lot of 100 to 200 pieces. Okay, low volume productions. So wood is something really at times we'll use less, because wood is difficult to cut and we don't have all the tools for the wood. Wood is something expensive also. So we prefer using a plastic compared to the wood. Plastic is something easier to cut. Plastic can be cut by a laser. Thicker wood can't be cut by laser. Okay. So plastic can be cut. Even a thicker plastic of 16 millimeter can easily cut by a laser. Okay. Clay modeling is something again which I have done it once. I'll show you the case study for a Yamaha bike. But this is what people used to do. They used to take a mirror and make only the half portion of the car, and you can see the reflection, and the car seems like as if full. So you don't model the entire car, but clay is something very interesting one. It's like, it's a clay which can be melted. So it's a wax clay, and you're going to chip out, and you're going to put in a tray, heat it, and just like spatula, you're going to apply that. It's a very interesting one. Okay. So the final layer is something very close to plus minus kind of a 1 millimeter accuracy can be done. So medical equipment, I have not used clay ever, because this is something not so, I mean, we are not so used to using the clay. Mostly medical equipment, we use thermoforming in the plastic sheet, because we are supposed to fit in the internal components. So medical equipment, to just check the form, we make the puff model. But fit in the internal component, we make the hollow prototypes made of a thermoforming processor. And I'll show you the process inside. So one case study here for the clay modeling, this was somewhere in 2004 with Yamaha Motor and Indian Limited. And we were given this CAD file, and this CAD file was really used to make a clay model. We understood how the clay model, what kind of a templates. You can see this kind of, these are like templates with an interval of 25 millimeter each. And we made several templates out of the entire length of the bike, because we are going to make the template something a kind of a checking tool. And once we laid the kind of and we made a kind of these green one is like a sort of a reference, and we have a center line as a reference, and a parallelity and the perpendicular is a reference to basically measure it accurately. And this is the kind of different tools we made. We cut the laser parts. I'll show you the laser parts here. This was the CAD model, and the fuel tank, the side kind of a cover, and of the seat, and this fenders was supposed to be like model. And we just studied that first, because if you want to make this in a accuracy of plus minus 1 millimeter, you should be using the kind of a template, laser cutout template. So we make this kind of templates which are there in plastic acrylic sheet, and very accurate one. And we consider how much the laying to be done. So you're not going to lay the entire full mass of like clay. You're going to have something internal. The bare bike was given, you can see that. And this bare bike is like fitted with you fix this bike, you're not going to move the bike, you are going to arrest the moment, and you have a wooden pattern. So this wooden pattern was going to save you on a clay, because this is, they're going to do two things. One is going to hold the clay in place, and at the same time going to give a shape to the overall kind of a clay. You're going to so these holes on the top is something to arrest the kind of the clay on top of it. And you fix this, get this fixed to the bike, all the tank and this thing. And after that, this was fixed. Then you have the other part which was fixed. And this is the industrial clay preparation. So what you do is like, you have this kind of in a form of a billet, and then you're going to scrap it out, and scrapping it and give you a small chips. And we have a kind of a OTG heater. It's like an oven. This oven, you can see this oven. So we're going to collect all these chips in a tray. We're going to put inside the kind of heated chamber that is going to melt, and with the spatula we're going to apply on top of it. So you can see that how this is the internal frame of the site kind of a part, and made in metal. And on top of it, this is going to be somewhere here, this portion, and that's where will complete the overall form. So the chassis was made first. The kind of internal structure pattern using wood and metal was made first, and we really fixed them tightly, firmly with a bolt that is not going to move anywhere. And the person from Yamaha, and we inspected it, like this is really fitted correctly, and we saw that how the fixing is going to take place on both the sides, and then the bike is actually ready for applying the clays. Okay, so you have a kind of a thing, a major part in a wood and metal, which is going to help you in saving the kind of the clay that you want to apply, and you started applying it. You can use your hand, you can just use spatula, whatever. Your clay become very soft, and slowly we have started applying. He was just demonstrating how to apply a clay, and we started applying to all the portions. Okay. And we built up a mass. You use simple tools like you have the knives, you have the spatula to apply this clay. So we have overall done, slightly you have to do more, and then you have to carve it out. So this is like, a good process we learned, and it's almost time-taking process. It took almost like 9 or 10 days to complete it. And we were like very systematic. We were going, first time we were doing it, we were like really going very slow, following a process. This is the kind of rough cut is done. Rough cut is done, and then it's time to use the kind of templates. Okay. So from the different views, you can see the pictures, and the bike is fully laid, and you have the kind of a templates. I can show that. You start marking some of the vital points there. You can see that we have the chart drawings on the soft board here. So we have taken out which template will go where, and from there, this is the kind of a template. We have a central kind of a member which show the center line, and both the side of the center line we have this template. So this is going to touch this particular face, and this will show the perpendicularity, and based on the kind of excess portion you want to grant it by using the kind of a scrapper. So use a different kind of a template. You can see that templates, and these templates are all laser cut, very precise, and the thickness of about 2 millimeter. We are going to use it very precisely, and going to do the sculpting job. So this was taken in a place, and finally we could finish a very good shape. And this is like whatever you see here is a form which is like plus minus 1 millimeter kind of an accuracy. And that is acceptable. Okay. So this took almost like 7, 8 or 9 days, I don't remember. But I think very precise work and form which is very close to whatever the Yamaha wanted, and completed it. Next portion is like we have the acrylic prototypes, which I have discussed earlier. Like this is one particular box we're making for a client, and you can see this box, like only the corner portion, because there is a shape in this. If you see this kind of a roundness here, because I am very fond of these kind of round surfaces, and I don't form them because I take a pipe. I use a lot of PVC pipe for giving the roundness. So when you can do this is a medical product only. So if you want to give a roundness to a product, and you want to do a fabrication method, We use this portion of a PVC pipe and really cut and paste together. And this is like a much easier than any of the 3D printing process. The 3D printing process of this size of part, we don't have in India. You need to then get it made in segments, and the segment is not going to come out correct. And if you see the final finish of this was immaculate finish. And with an accuracy of again plus minus 1 millimeter, we could really make it. We take 1 year to measure all the dimensions because this cannot be bigger than a millimeter. Okay? This is very precise. So this is the process when we locally form it and fabricate it and use acrylic, this kind of a glue to join the parts together. This took about say 20 days to time to complete it, but very precisely done. So if you want to get a kind of a box like that, this done for a medical product, yes, this kind of vacuum forming and fabrication method is the answer. This can give you a really good, if you don't have a model maker, you can really hire some of the carpenters who understand the drawing and inspire them to really become a model maker. And then that's how even I have done it. I've inspired one of the model maker to become a model prototype maker. Okay, so these are the other example of this molded process. Like we have the existing torch, we have shown the new design, and design got approved. And we started with the CAD, design was approved. What are the internals? We play with the internals, and we really make many iterations of the CAD. All those changes are done at the CAD stage. There were several iterations at the CAD stage, only like in 7 or 8 rounds of it. Smallest point also is taken into consideration because these are going to decide on the overall size and weight of all such things, the dimension, because you're going to take a 3D print. So this model was finally done, and this is like you can see that this is having all the details, all the functional detail and the aesthetic detail. Aesthetic details are which are the outside of the product, but the functional one is something which is inside of the product. And that's how you really assure that whatever parts you have done, your details you have made it, you're going to house all the internal components. Okay. And when the CAD is fully done, then we approach a kind of a 3D printing guy and who does the 3D printing of the same model. So 3D printing with an accuracy again few microns, and you get a 3D printed part. That is another prototyping method. For a smaller product, that is really good. Because if you want to make a small handmade fabrication prototype, this will never ever come out. That is so precise. Okay. Larger part, yes, this is the best method to go for manual method, but the smaller part is really good to go for a 3D printing part. And we use a process called SLA process we have used, and a very good kind of finish that has got it. On top of it, the companies also get this painted in desired color. If you want, they're going to apply a color and finish, and in case of desired color, you want to paint it and give it to you. So the purpose of this is like, whenever we do this kind of a torch, they are going to take a print, they're going to fit in the batteries, the reflectors, the kind of other components, and make it complete. And they're going to really show it to the marketing. This is how the new product has come up. Unless until this phase is done, many of the companies, they're not going to fire the kind of a mold, because mold is something, mold for this will be like 15-16 lakh rupees. And one has to be really careful enough. And this prototype gives you all components to move. This is the kind of a torch, but this could be any medical product, and you're going to follow the same process, right? So in 3D printing additive type, we have the kind of FDM, something which is additive type. You have the tray, moving tray, and you have the kind of model here, and this is building of models over here. A fine layer of model is getting built up. This is additive type. We have different methods. SLA, SLS, FDM, these are like commonly available, but these are like not so commonly available. We can print, as in today, we can print metal also. There are vendors in Delhi, there are vendors in Bangalore who can really do a good metal printing job for you. In case you want to have very intricate part, a small part, metal, go for 3D printing metal. Or bigger part, it can be done by CNC milling operation or a turning operation, right? So printing has got many technology. I'm not going to go into detail because these are like, really we know that what is an FDM or SLS or SLA process. But you can print many kind of body parts easily nowadays, because these are again very intricate, small intricate parts, and really don't give a try to make it by hand. If you want to have a part like this, solid one, rigid one, 3D printing is the answer. But if you want to have a part like soft like this, you're going to take a kind of a master in a solid one, which is rigid, and using that master and a silicon mold. So you have a silicon mold here. This is silicon mold. Using that as a master and silicon mold, you can really mold a part in a soft material called silicon or other parts. So we can make any kind of body part which are in soft colors. We can have the kind of make a bigger kind of a print. This house can be printed using 3D and likewise. So one last case study that I really want to discuss here is like CM X-ray. And this is actual fabrication of a prototype. People say designer don't do the internals, but I think I'm the person who does the inside first and then come to the outside. And this is what a new method was discussed, proposed to them to use a electrical actuator in place of a chain and gear and lead screwdriver. I said, no, that's not done. Medical equipment internal has to be really good looking components, and they make this, fabricate this prototype. And this is something, a mass which is like tube head and the image intensifier in the front, and both are having a weight of say 125 kilogram, with a cantilever load of 1.25 meters. So this is having a really a good amount of load here, and this actuator here is going to bring this up and down by 400 millimeter. And they were not sure because they are going to do this for first time. So one person was sitting in one corner and they tested for almost like 3 months continuously, day and night, up and down, up and down. When the product really succeeded and no problem, then they really approved this kind of internal mechanism, which was very new for this CM industry. So we did the internal first year, and for doing this internal, you're again going to fabricate these kind of a part using CNC laser and welding and joining this part, mechanical fabrication with an accuracy. So this actually part which was done, you can see the kind of intricacies here. So technically, when this mechanical system is proven there, and this particular CM has got different kinds of motion, variety of motions are there, and you're going to achieve all the motion using the same thing. So we did the internal first, and then we started the external forms. So you can see again the larger block of form. Okay. We're not going to really leave that. We're going to make a full-scale form model that was discussed, made, and really put in front of that, the first prototype. And this was like really liked, and finally we took a decision, because this is 1:1 form. You can see that how this internal and external are going to match together. And unless until you do that, you're not going to take a decision. But after this, you're going to make a FAPI die, and a FAPI die is like again a sort of investment. And this investment is supposed to be like really, one should be careful enough, because and there's the final prototype that you see, so which is having a really reasonably good amount of form on the external one, and the internal also like solid kind of engineering, mechanical engineering, and this gave birth to a new product called CM X-ray, and they were really impressive one, and this got a lot of buyers in the kind of industry. So the final product is doing very well for last, I think, 12 years, and they are able to sell within the country, export out of the country, and then doing so well. And this one I've already covered in the last video. We're going to skip that. But the process is very simple. You can see that we convert this into a drawing, and these drawings are the internal components. And how we start with the kind of the pipe we have, PVC pipe, because again model making this particular exercise was done keeping in mind the PVC pipe only. The design itself was done because they wanted to manufacture in a very low volume. I said, okay, why not? Next PVC pipe is a part of design. So one piece, such piece cost is 20 or 30 rupees. For maybe less than 100 rupees, and then how you really bring up a design around the PVC pipe construction. So you can see this process was like, again, the front portion was supposed to be in a hand molded component, but other portion, this is how we proceeded further, unless until you fit in all the component, you have to take some decision at the time of prototyping. You've done all the CAD at the engineering stage, but you need to be careful, and you need to be really considering all the kind of, because if you want to use a gasket here, you're going to use a pipe which is going to be sufficiently fitting between the glass and this PVC pipe. Okay, especially you want to get a kind of this developed. No, this is not done. There's a kind of investment and time, and no one has that time with us. So we need to consider so many aspects while prototyping. That's so cost effective. Because if you go for a 3D printing of such big part, 2 lakh rupees for 3D printing. Who is going to afford that? And this entire part was made in just 50,000 rupees. Entire assembly, sub-assemblies, and then the rest of the part. We can see that this took little time, but I think this is the way we used to follow in our industry. Even if we have money, we won't pay for 2 lakh for this kind of prototyping. You have to go cost effective. So two of my kind of labor, which is I'm paying 20,000 rupees or 40,000 rupees plus space, and within 50,000 I should be able to get this. Raw material is hardly any cost. Only the kind of a thing you are going to encourage, like the internal components are given to you. You have the PVC pipe, just 2,000 rupees raw material, and then labor cost and skill cost, and then you're going to get a very good amount of, reasonably good amount of prototype, and this is a functional model. We can fit in, we could fit in all the really internal components, and we can test it out. The final thing which has come up much more neater and within, I think, timeline of 20-25 days. Okay. So the kind of a gap we see in the prototyping here is like, prototyping currently takes more time than design and engineering. The lack of facilities are there. This is a kind of gap we need to understand. And if that is so, then what is the kind of an answer? We need to either look for some other sources outside. Even outside is a very expensive one. Prototyping need all kind of machines, not only one machine. You need a variety of machines. Suppose you want to print a name on top of any component. How are you going to do that? One of who is going to do that? No, you're not going to make a screen print for that. Okay, so you need to understand what are the things which can really be leveraged, because there are small parts, there are bigger parts, they're part made of plastic, they're part made of wood, they're part made of rubber. And all such things are like really needed to complete a prototype. Okay, prototyping need a skilled manpower, and we are lacking a skilled manpower. So basically, because this is something which is iterative. It's not one go and you have done it. If you've done it one go, then you have to refine it to the next go, and then how it's completed. So way out is something like, with government interventions or big company interventions, prototype facilities can place certainly a good role, with which we can achieve a kind of speed and cost, because cost is one thing and speed is also one thing. Because I remember doing the medical product at time, company asked us to deliver the prototype in next 2 weeks time. And that is so tight for us. We are so helpless. Okay, private companies collaboration with the design houses and institution. This is very much needed because they have money. When they need a kind of a prototypes and the thing from design houses, they should actually invest in. For them, it's like a couple of crores with more made like really a hurdle. Or there could be an investor who realizes the need, and because there is a kind of emerging need of a professional prototype maker in a country. Because this is no more a kind of a hand operation. Let the machine take up all the kind of an activity, machining or laser cutting and everything in there. Then you're going to get an actual prototype, and within no time. If we're going to file it or sand it, it may be like again human intervention and some kind of errors. So these are the things about the prototyping. I think medical or any sector, you need a prototype, okay, and don't need only one. You need a couple of them to compare, and that's how you should having really, this is going to help you out in a good way and taking a right decision. Okay, with this, I think I've completed the last session here, and any questions I can really take it up.
Thank you, Mr. Sudhir Kumar and Professor Tanuja Shore. We have some questions from the audience.
Question number 1. This is with respect to the shaft cutter. How does a customer check the reliability of the shaft cutter, given that there are other factors like vibration, etc.?
See, plastic itself is something which can take any kind of a vibration. Okay, but plastic is not that rigid. If you select a material called PPCP or polypropylene, it can flex a lot. So vibrations have no role there. Okay, at the same time, that is tougher enough, it won't crack. Only thing you have to need to make the kind of a material UV stabilized, because these products are going to be in sun. Okay, the material is UV stabilized, nothing is going to happen there. It's very easy to produce.
Okay, thank you, sir. So we have another question. What are some good materials to make prototypes of large medical devices?
ABS. ABS is really good material. ABS sheets are there, ABS blocks are there. They're really good material to make a large prototype of, all this MRI machine and the CT scan. I've really virtually seen in China, where in almost like 18,000 square feet of space, they were making all big kind of part made of ABS. And 5 millimeter, 10 millimeter, 15 millimeter thicker one, they used to get, because ABS is something very stable. There is something which is dimensionally so accurate. Okay. If you want to make a clean cut on ABS, it's just like going to machine like in a metal. And if you're going to join it, it's become a perfect joint. Okay. You can really sand it, machine it, or you can grind it, give any kind of a shape there. You can thermoform it. Very good material.
Thank you, sir. This was the end of the Q&A session. I'm sure the audience had a great time learning about the healthcare systems and devices. We have now come to the end of day 1 of DEW 8.0. I would like to thank Professor Abhay Kumar Kuthe and Mr. Sudhir Kumar for being a part of this momentous event and sharing your valuable experience with us. I extend my heartfelt gratitude to the participants for being such an amazing audience. Day 2 of DEW 8.0 will start at 9 a.m. tomorrow on the same link. We look forward to meeting you all there. Thank you and stay safe.
Yeah, thank you all of the DEW team also, and especially to you both. You have really put in a good amount of efforts, and to Rubini and Brenda, really, and all the team members who have been part of it, who are not visible here, but I think you have great kind of effort. I'm really thankful to you. Thank you so much.
Thank you. Thank you, sir. It's always a pleasure to have you. Thank you.
Okay, bye.
Bye.